We'll start. Write the next heading. Optical instruments. Optical instruments. The last topic. Optical instruments. Optical instruments. We will study just an overview. Mainly three things will be there. Mainly three instruments. One is simple microscope. This is the first one. Second one is compound microscope. Third one is telescope. Telescope, especially called refractive telescope. Okay, so optical instrument means equipment. Correct? If a voltmeter is an instrument, voltmeter is used to measure voltage. Similarly, ammeter is used to measure current. Adhe maari instrument is used for an optical illumination, optical purpose use pannu. Ipo ungalku veduna theriyum microscope you are already used in lab, correct alle? Simple microscope. Which microscope you are used in your lab? Compound microscope you are used in the lab. Okay, ipo simple microscope earlier days il irukkanada. This is not nobody is using, but വളരെ കോമൺ ആയിട്ട് ലാബിലെല്ലാം യൂസ് ചെയ്യുന്നത് കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ് ആണ്. ഹൈ എൻഡ് അപ്ലിക്കേഷൻസ് വരുമ്പോൾ ഇപ്പോൾ ഫോർ എക്സാമ്പിൾ ചിപ്പ് ഡിസൈനിങ്, അതേപോലെ DNA സ്ട്രക്ചർ റെക്കഗ്നൈസ് ചെയ്തിട്ട് അതെല്ലാം യൂസ് ചെയ്യുന്നത് ഇലക്ട്രോണിക് മൈക്രോസ്കോപ്പിൽ പോയിടും. കുറച്ചുകൂടി റെസൊല്യൂഷൻസ് പവർ അധികം. ഇത് നോർമൽ യൂസ്ക്ക് അഫോർഡബിൾ കോസ്റ്റിൽ വരുന്നത് ഇത് ഒരു 1000 rupees റേഞ്ചാണ് ഈ മൈക്രോസ്കോപ്പിൻ്റെ എല്ലാം കോസ്റ്റ്. Okay, compound microscope. Telescope, you know. Why we use telescope? In order to see the large distance object. Correct? Like galaxies, ademari stars, moon. Adella observe edukana normally telescope use cheyunnathu. Okay, but question is not like that, of course. Question is a numerical question. So we'll start with one. First write the heading simple microscope. Simple microscope. Okay, so below we will write some few points. This is in general microscope is used to, you can write here simple microscope. Microscope in a concept to start in simple microscope. Microscope is used to magnify small object and form its large image Okay, then write a subheading, just a small subheading, least distance of distinct vision. Least distance of distinct vision, other term we will see near point, far point, some terms will see. These terms will comes in the your question. Least distance of distinct vision. Least distance of distinct vision. Least distance of distinct vision. Distinct vision. Least distance of distinct vision. Word itself indicate. Least means minimum. Distance means distance itself, and distinct means what? Difference, clear. Correct? So least distance of distinct vision in a simple terms. Suppose I have this pen in my hand, right? If it is very far away, now I can see the camera, I can see the projector, I can see the fan, and I can see each of your faces. But if you are taking one pen or something like this one, and if you keep on moving towards your eye, at some point you will look like it is blurred. Correct? So normal eye, how much distance away from my eye so that I can clearly see this pen? Our distance is least distance of distinct vision. If it is very large distance, if our camera power box and a power box I can see very clearly. A power box if it is coming very closer to my eye, one stage blurred eye because my eye cannot focus it. That's not a problem. Everybody. So it is a normal human being nature. So one distance the blood up. Appa minimum distance minimum distance away clearly visible. After that I can see, but if it is coming towards my eye again, I cannot see the object. It will become blurred. Our minimum distance is called least distance of distinction. I can see clearly. It is a standard value 25 centimeter. Okay, so we'll write the definition. It is a minimum distance from the eye. It is a minimum distance from the eye so that I can see the object very clearly. It is a minimum distance from the eye so that we can see the object, so that we can see the object clearly. We can see the object clearly. For normal eye, next point, for normal eye, capital D is equal to 25 centimeter. 25 കാരണം minimum distance ആണ്, I can see an object very clearly, very perfectly at 25 centimeter. Beyond that also my viewing clarity will be reduces. If I am taking closer to the eye after 25 centimeter also, clarity will be reduces. 25 ആണ് ആ ഒരു perfect range for normal eye. Okay, so this is called least distance of distinct visions. Next heading, visual angle. Next heading, visual angle. Visual angle, we will going to study two visual angles. Okay, so we'll write visual angle two types. Visual angle two types. Visual angle two types. The angle is called alpha. Second one is called beta. We'll understand. So within alpha in the bracket later, angle made by the object with eye, angle made by the objects with the eye. Beta means angle made by the final image with eye. Which means we can explain using some diagram. Suppose this is our eye. Suppose this is our eye. We are seeing an object. Suppose this is eye means it's a lens. Correct? It is a convex lens. And an object here. What will happen? There are different rays will be here. So our eye will be created, image will be here. Image is an inverted image. Eye is taking an inverted image. Our brain is processing and giving a correct image. That is what happening. So this is an object. So height of object is h0, and this is an image created by the eye. It's an inverted image. About object with the eye, the angle is called alpha. Angle made by the object with eye. This is object made with the eye. It's called alpha. Angle made by the final image. This is the image with the eye. This angle is called beta. Okay, so two angles will be there in visual angle. One is called alpha, one is called beta. Angle made by the objects with eye is called alpha. Angle made by the image with the eye is called beta. Final image. Got it? Draw the diagram also. This is eye. Once done this one, right? Magnification. magnification of microscope, magnification of microscope, magnification of microscope. Microscope is represented using a letter called capital M. Capital M equal to beta by alpha. Very, very important. Beta by alpha. Capital M equal to beta divided by alpha. Next one. Definition of alpha. Definition of alpha. We will see what is alpha bit details. That's all. Okay. Definition of alpha. This definition of alpha means this is an object, right? I can see an object when it is at what distance away? Least distance of distinct vision. That's what we say. So this is called alpha. So I am taking here tan alpha. So what is tan alpha from the diagram? H0 by D. This alpha value is very lesser, very small value. So this tan alpha, similarly we will equate sin alpha into tan alpha. Tan alpha can be approximated to alpha for small values. Sometimes we will also write a sin alpha can be approximated. It is approximately equal to tan alpha. This is approximately equal to alpha. All are correct. Okay, so tan alpha, this become alpha is equal to H0 by D. This you will use in majority of the problems while we are solving. H0 by D, right? Definition of alpha. This diagram mark here, least distance of distinct visions D. Tan alpha is approximately equal to alpha. Alpha is H0 by D. This is a standard equation. These two, whatever I keeping in the box. This you have to remember. This you have to remember. D, least distance of distinct division. Normally the value will not given in the question. Sometimes they will give the value something like 15 centimeter, 20 centimeter like that. So in that case you have to take the value. Else you have to take our standard value 25 centimeter. That is the way of answering. Correct? Value koduttirna value edukanam. Illana 25 eduthirna. Avladha. Next one. Construction of simple microscope. Construction of simple microscope. Below, right? Simple microscope is made up of a single eyepiece lens. Simple microscope is made up of a single eyepiece lens. Okay, eyepiece lens means the lens in which we are looking. Okay, nearer to our eye. Normally lab you have seen microscopes will have two lenses. One is nearer to your eye and one is nearer to the object. So it has two lenses in your compound microscope, whatever you are using in the lab. But in simple microscope will be consists of a single lens, and that is a convex lens. Before going to this topic, we have to revise what we have learned bit earlier. For example, this is the focus, first focus. If an object is placed between where will be the image will be formed? So here I will mark it 2 points, F and 2F. Where will be the image will be formed? Beyond 2F, beyond C. C means 2F. So image will be formed will be here. It's an inverted image. Okay, this already we know. Similarly, instead of placing the object will be here. If I am placing object focus, where the image will be formed? Image is at infinity because it is a parallel rays will go. One ray will go like this and go like this. Second ray will go like this. Both are parallel rays. This is what we learned. So instead of going like this one, if an object is placed, the same principle, whatever we have learned, we are using here, nothing else. Between focus and object, where will be the image is formed? Between focus and optical center, Optical center vechina how the image will, where the image will be formed? Same side. So what type of images? Can you look back to the notebook in case if you are doubt? Notebook again. Image formations by convex lens. It is okay. We may forget, but just to see. അത് വെർച്വൽ ഇമേജ് ആവും, ഇറക്റ്റ് ഇമേജ് ആകും, ബിഗ് ഇമേജ് ആകും, സെയിം സൈഡിലായിരിക്കും. Okay, if you are placing an object between focus and optical center, image formations by a convex mirror, we have drawn many diagram, right? Object is at 2f, object is between f and 2f. Adile last case I guess. Correct, last case. Object is a virtual object, which means I will get an object here. This is what we have seen. If object is placed between focus and optical center, we learned this one, image formation by a convex mirror, convex lens, then image will be formed is a virtual. Virtual means what? It's not in the reality, right? It is a virtual and erect image. The same principle is using in simple microscope. So below, right, simple microscope is using the principle of simple microscope is using the principle of image formation by a convex lens. Image formation by a convex lens where object is placed between f and optical center. Where object is placed between image and optical center. Where the object is placed between f and optical center, and the image is formed. What type of image? Enlarged or magnified, enlarged, virtual, erect image. That's what we have seen there, right? Enlarged, virtual, erect image will be formed. This is what we have seen in the diagram, right? Okay. Same principle we are using will be here in construction of a simple microscope. So construction. So the same idea, no difference. So simple microscope is consist of one lens. So we have already written it consists of eyepiece lens. So you can just mark now focus and optical center. Will place an object will be here. What all the rays are going? One ray is parallel to the lens. So where it will go? It will passes through the focus. So it will passes through the. Next one is where we have drawn. If you look into the diagram, going through the optical center. So what will happen? This diverging lines. We mapped the point. This will be beyond 2 years. Image will be. This is a virtual image. This is what is happening. Next, the point is, I know the definition of alpha. Okay, our aim is to find out what is the purpose of microscope. I want to see a small object magnified in a bigger size. Correct. That's what you are looking different items in the biology lab while keeping the microscope, and you are looking and you can see the things in a zoomed way. Correct. That's the purpose. So the purpose of the microscope is to get the smaller object become bigger object. So this is a smaller object, and you are getting this bigger object. So this is like almost it is 3 times or 2 times it is multiplied. Bigger size. Okay, so this bigger size you are getting because of this lens, one factor. Second one is what? The position where you place the object is important. Okay, where you place the object, if you are placing the object very closer to the lens, then you are getting a bigger image. So 2 factors are depends upon the magnification of a microscope. One is where you have placed the object. Second one is what lens you are using. You are using convex lens, simple microscope. Object is placed between focus and optical center. So the measurement of magnification, how I can say a microscope is a good microscope, or how I can say a microscope is a bad microscope, depends upon its magnification power. Good magnification, I will say good microscope. avlo magnification illana okay nu sollum kettalla. So in order to measure the magnification, in order to measure the zooming power of this lens, we will use the term called magnification. So what is the magnification of a microscope? Beta by alpha. What is alpha? Alpha we already know. Alpha is equal to, it's a standard, h naught by d. I have to place the object at a distance of 25 centimeter from my eye. Eye is 25 centimeter distance. This will fall between focus and optical center object. So distance will be equal to 25 centimeter. Height of object means this height. This height is height of objects. Okay. So this height of object. Okay. Now this is an eyepiece lens. So from the lens, not from the eye, from the lens, this distance is taken as u0. For example, object distance. I am taking a u0, object distance. What is called beta? Beta is the angle made by the eye or the lens with respect to the final image. So this is the final image, right? Final image. This is a triangle, and this angle is considered alpha. This is with respect to final image. This one is a not alpha. It is beta. This is a final image, right? Final image, and this angle is called beta. From this one, can you tell me what is tan beta? This is a bigger triangle. This is height of image. Okay, but I want to get tan beta. From this small triangle also I can take a tan beta. What is tan beta? H naught by u naught. H naught by u naught. This is called tan beta. So tan beta is approximately equal to what? Beta. Beta equal to h naught by u naught. Understood that this one? Already we got alpha. Alpha is equal to h naught by d. Okay, now we'll go magnifications m equal to what we got? Beta by alpha. What is beta? We know h naught by u naught divided by h naught by capital D. What is capital D? Least distance of distinct division. These two cancel. D by u0 is the magnification of simple microscope. Understood? How the formula, how the things. Alpha already we know. We don't want to touch. We need to get beta so that we can substitute here. We can find the equations. The value, if it is given question, you have to take it. Else it is 25 centimeter. U0 is the where you have placed the object. Normally, while seeing like in a school lab, you have a knob will be there. You will adjust the knob back and forth, right? In order to clearly see the objects. So, which means you are actually adjusting what? You are 0, but D is fixed. From your eye you want to see it very clearly at a distance of 25 centimeter, but you are adjusting there what? U0, the distance between that lens and the object, you are adjusting with the knob. Understood? So this is clear, right? So you can write. Actually this image will be formed beyond 2f. Whatever we have drawn in the previous diagram, 2f nipper beside what I want. Object placed between O and opticals O and F. Image formed is virtual, enlarged or zoomed images of, but its erect size and magnification D by mu 0. between 2f. Okay, I didn't remember. Between 2f and f1. Okay. அது சேஞ்ச் பண்ணலாம். எப்படின்னு கேட்டீங்கன்னா பக்கத்தில் போகும்போது வெளியே டிஸ்டன்ஸில் போயிடும். எப்பொழுதுமே அதே மாதிரி சொல்ல முடியாது. இப்போ 2fக்கும் எஃப்க்கும் வெளியே வரேன், 2f தாண்டி போவோம். எப்படின்னு கேட்டிங்கன்னா ஆப்ஜெக்ட் க்ளோஸராக கொண்டு போகும்போது அது இங்கே வெளியே போயிடும். அப்போ ரெண்டும் கரெக்டாக இல்லை பீட்டா കാരണം ആൽഫ എന്ന് പറഞ്ഞാൽ ആൽഫ ഈസ് മെയ്ഡ് ബൈ ദ ഒബ്ജക്റ്റ്. അതായത് ഇതും ആൽഫ ആയിട്ട് വരും വിത്ത് റെസ്പെക്ട് ടു ഒബ്ജക്റ്റ്. ബട്ട് ഈ യൂസറൊക്കെ പകരം എന്നാ വരും, ഡി എന്ന് വരും. ഇവിടെ ബീറ്റയും ആൽഫ ആക്ച്വലി സെയിം ദാ. സോ ആൽഫ ആംഗിളും ബീറ്റ ആംഗിളും ഇവിടെ സെയിം ദാ. ബട്ട് ആൽഫ എന്ന് എടുക്കുമ്പോൾ ഈ യൂസറൊക്കെ ബദല ക്യാപിറ്റൽ ഡി എന്ന് വരണം. അവിടുത്തെ ഡിഫറൻസ്. ബട്ട് ഇമേജ് എടുക്കുമ്പോൾ ഈ ഒബ്ജക്റ്റ് ഡിസ്റ്റൻസ് അഡ്ജസ്റ്റബിൾ ആണ്. ഈ കറക്റ്റ് ഇമേജ് ഫോക്കസ് ചെയ്യുന്നത്. അതുകൊണ്ടാണ് ജനറൽ ആയിട്ട് U0, ബിക്കോസ് U0 ഇസ് എ വേരിയിങ് ക്വാണ്ടിറ്റി. ഡി എന്ന് പറയുന്നത് കോൺസ്റ്റന്റ്. നമ്മുടെ ഐൻ്റെ പവർ നമുക്ക് ചേഞ്ച് பண்ண முடியாது. ലെൻസിൻ്റെ ഇത് നമുക്ക് അഡ്ജസ്റ്റ് பண்ண முடியும். അതുകൊണ്ടാണ് ലെൻസിന് വേരിയബിൾ U0 എന്ന് വരുന്നതും ഐക്ക് ഫിക്സ്ഡ് H0/D എന്ന് വരണം. ഒരെങ്കിലോ ഡി ഫിക്സ്ഡ് ആയിരിക്കും, കാരണം ഐ ഫിക്സ്ഡ് ആണ്. ലെൻസാണ് നമുക്ക് ചേഞ്ച് ചെയ്യുന്നത്. ലെൻസ് ചേഞ്ച് ചെയ്യുന്നത് കേട്ടിനാൽ അങ്ങ് ഒബ്ജക്റ്റ് ഫിക്സ്ഡ് ആണ്. ഒബ്ജക്റ്റ് നിങ്ങൾ സ്ലൈഡ് മൂവ് ആകും. ബട്ട് നിങ്ങൾ ലെൻസ് പോകുന്ന U0 ചേഞ്ച് ആയിട്ടായിരിക്കും. ക്ലിയറാ? ഓക്കെ. One question what he is asked is, can this angle will be alpha because this is also made with object? Yes, this angle can be alpha, but provided this distance is capital D. അതുകൊണ്ടാണ് H0/D എന്ന് എഴുതിയത്. കാരണം D എന്ന് சொல்லுന്നത് എന്നാ, for normal eye the least distance of distinct vision. The capital D for a normal eye, it is fixed. Nobody cannot change. It's fixed. But for an image, to get a clear in order to get a clear image, the object distance has to change. So who will change? My eye will not change, but who will change? Lens will changes. So for an image, H0/U0, because U0 is a varying quantity, but for an eye it is H0/D. D is a fixed quantity. That's the difference. Understood? Okay. So next one, condition for maximum magnification. Subheading ആണ്, രണ്ട് subheading വരും. Condition for minimum, condition for maximum. Conditions for doubt inda illa. Okay. Conditions for maximum magnification. Conditions for maximum magnification. Okay, conditions for maximum magnification. And a bracket like that for strained eye. Strained eye. Why this kind strained eye means, in order to get a maximum magnification you will struggle with a microscope, right? Definitely you will struggle with a microscope. That's what it is saying, like strained eye. You will strain much in order to get maximum magnification. So what is the condition for magnification means? The object is at a distance of, tell me the condition, this is plus or minus U0? Minus U0. Image at a distance of minus D, least distance of distinct. These are the conditions to get maximum magnifications. Next we know the lens maker's formula, 1/f is equal to 1/v minus 1/u. So 1/f will substitute here 1/1 values. What is 1/v? 1/minus D minus 1/u0. ഇവിടെ ഒരു എക്സ്ട്രാ മൈനസ്, ഇതിൻ്റെ മൈനസ് ഇങ്ങ് വരും. കേട്ടല്ലേ? We'll simplify this. 1/f is equal to 1/u0 minus 1/d. Okay, 1/u0 alone I am keeping there. So what I will get? 1/u0 equal to 1/f plus 1/d. Next I know the formula of magnification, m equal to d by u0. I am substituting for u0 here. So what I will get? D into, what is 1/u0? 1/f plus 1/d. Okay, multiplying inside. So your d by f, d by d 1. So 1 plus d by f This is the formula for f is the what? Focal length of the single lens. Here we have only one lens, right? So simple microscope a lens in the focal length. D is fixed if it is not given in the question. So write down. So conditions for maximum magnification m equal to 1 plus this general equation and magnification is general equation. Whenever question is given like for a strained eye, means maximum magnification meaning. To get maximum magnification, this is a condition. Anyway, object is fixed to u equal to u0, where the image has to form. Image has to form at a least distance of distinct. A correct image form will get the maximum magnification. Then this is the formula. M equal to 1 plus d by f. Important 1 plus d by f. Okay, the question will be based on the formula and other steps. Okay, next, this is the condition for strained eye or maximum magnification. Maximum magnification means if the object is moving closer to the lens, image will become bigger and bigger. Okay, when I will get the minimum magnification? Exactly this one. Object is moving left, far away. Okay, so you can conditions for minimum magnification. Within bracket you can write relaxed eye. You will never stretch much. Relaxed eye. Conditions for minimum magnification. Object is at minus infinity. Correct? Left minus represented. Below, right? Conditions for this one and for a relaxed eye. So within a relaxed eye, maybe you can write one sentence. I will not strain much. That's question paper words and what I'm telling. I will not strain much. Sorry, not. Object is at infinity. Fixed. U is at minus u naught. Image is fixed. I don't know where the image is formed. You are not bothering about the image. That's the meaning. Understood? Condition for maximum magnification means in order to get magnification, the image should be at a distance of least distance of distinct vision. Object should be there. So in this case also, of this one, not bothering. Image is at infinity. Infinity sense minus infinity. Everything on the same side. Will you lens maker the same steps? 1 by v minus 1 by u. 1 by f is constant focal length. V is what? Minus infinity minus 1 by u. U means what? U means what? Minus u0. 1 by infinity value? 0. So this become 1 by u0. Okay, so what will be the magnification formula? Then come here. M equal to, what is the magnification formula? General formula d by u0. What is 1 by u0? 1 by f. So m equal to simple on d by f to remember. Maximum magnification remember the 1 add 1 plus d by f. Next one is m equal to d by f. Okay, relaxed eye means the word itself relaxed. The image will be formed. You will be just leave it out. But for it to get a maximum magnification, it's important that your image at a least distance of distance. That is a perfect position for your eye. That's the meaning. So you will struggle. So relaxed eye, strained eye. Okay. So below write a summary. Below write a summary. Below write a summary. Just write a summary. Okay. As a sum. Simple microscope. രണ്ട് magnification cases. 1 plus d by f. Another one is d by f. General formula. This is called strained eye. This is called relaxed eye. Remember that wording itself. And I can say this is the first point. Second point in the summary. The magnification should be greater than or equal to d by f. And magnification should be less than or equal to 1 plus d by f. Correct alla? 1 plus d by f kum d by f ku ulla irukku magnification the value. Because this is a maximum, this is a minimum. Next heading. Compound microscope. Compound microscope. Compound microscope. This is main things which from here, and general formula also you know, right? D by U0, U0. Next one, compound microscope. Compound microscope, how many lenses? Lenses. So compound microscope. Below right, compound microscope make uses two lenses. Compound microscope make use of two lenses. Objective lens and eyepiece lens. Objective lens and eyepiece lens. Objective lens and eyepiece lens. Objective lens will have the smaller focal length. Next point, objective lens will have the smaller focal length as compared to objective lens will have smaller focal length as comparable to that of eyepiece lens. Eyepiece പെരുസായിരിക്കുന്നുള്ളതാണ് meaning. Focal length ചിന്നമ്പോൾ lens ചിന്നതായിരിക്കും. So next what we are going to do will be here. We have two lenses, eyepiece lens, sorry, objective lens and eyepiece lens. Okay, so this is objective. Okay, you can draw along with me so that we have to write notes also. Eyepiece lens. This is a bit complex diagram. You can take some reasonable amount of space on your notebook. This is a bigger diagram to vary. That's all. Objective lens, eyepiece lens. Okay, we will construct the diagram. That's what we are going. Next one, I need a principal axis. Principal axis, central corner line. It's called principal axis. I got a principal axis. Okay. Next, I'm one focus. Okay. Fine. Next, what I am going to do here means the basic principle is this objective lens. I will place it here. This will create what called an image, and that image will act as an object for eyepiece lens. This is what we are doing. But what I am not going to do means I am not placing object between F and optical center. I am placing somewhere beyond F. It may be F and 2F or at 2F or beyond 2F. Anywhere you can place it. But I am placing object. Okay. So this object will definitely form an image. Correct line. So we'll first draw a parallel line, passes through focus. So passes through the focus. Focus. Okay. Next line is going where? Optical center line. So this will come here. So this object I am giving, for example, to understand. Now this is an inverted images will be formed, will be here, and this inverted image is A dash B dash. Up to this is you know, right? Can you draw this one? Then we will move further. up. A dash, B dash. Parallel to principal axis, passes through focus, going through optical center, and it's undeviated and creating an image. Okay, but how this microscope, so up to this drawn up. Okay, now how this microscope work means this image formed by the objective lens must fall between the optical center and the focus. It will design in that way, which means the image created by the objective lens should fall or must fall between optic and focus of lens will act as what? Simple microscope. This part is a simple. Now in case of a simple microscope, where this object is placed? Between focus and optical center, right? Here between focus and optical center. So what will happen? Virtual image will be formed. So a parallel ray passes through focus like this. This is a focus, passes through focus. Next one, between focus and optical center. So what will happen? Next ray, it's a diverging ray. Both should be diverging like this, diverging. Okay, because it is placed where? Optical center and F. So what will happen? We will extend these two lines. Correct? These two lines. So what type of image you will get? You will get a virtual enlarged, not inverted, because this is already inverted here for eyepiece, but comparable to the first object it is inverted. Okay, for the eyepiece lens, for the eyepiece is similar to a simple microscope, but in case of a simple microscope this object is placed like this, so image I got like this. But here what will happen? Because of the eyepiece lens, A dash, B dash from AB, and that is inverted, and this is falling between focus and optical eyepiece lens, and this structure is a simple. This create an image will be here, and with respect to the first object, but for the object of the object edutna, eyepiece lens object is this one, right? Eyepiece lens is the object. First object edutna compare is inverted alla, same size, same format da. But now this is our object. For us, I don't know what is doing inside the microscope, but for us this is the object and this is the image. Image is enlarged, but images is inverted. This is called compound microscope. But what is the difference between simple microscope and compound microscope? I can say this whole part to this is similar to what? This is a simple microscope. Okay, so this is a simple microscope is added with an objective lens, will get a compound microscope. Understood? Then draw the diagram. Here we have to learn many things, many questions will come. part is simply a simple microscope. This part, full, it's a simple microscope. And simple, I can say an objective lens with a simple microscope is equal to compound microscope. So we will write here an additional point. Objective lens plus simple microscope is equal to compound microscope. Objective lens plus simple microscope is equal to compound microscope. Clear, right? Okay. Next, what is our aim? We need to derive an expressions for magnification. Correct? That is the main thing. Where beta is located here? Alpha, I know it is h naught by d. Correct? Alpha is h naught by d. So beta is the angle made by the image. This is an image made with this lens. So this angle is called beta. This angle is called beta. This is an image made with the lens. This angle is called beta. So mark beta. Second lens is eyepiece lens beta because this is with respect to image. Next, I want to mark additional things. This is object distance for objective lens. Object distance for U0. Okay, U0. And A dash, B dash is the image formed by which lens? Objective lens. So this distance is given as V0. So that is U0 and V0 clear. And focal length of the objective lens F0. F0 is the focal length. Everything is clear. Focal length of objective lens F0, object at U0, image at V0. Okay. Okay, then below write this point also. Focal length of the objective lens F0. Below write. Focal length of the objective lens F0. Diagram still you write because later time you want to understand when you are doing revision. So the focal length of the objective lens is F0. Object distance is U0 and image distance is V0. Object distance U0, image distance V0, focal length F0. Perfect. Then listen to the board. Again, we will write and next we will listen. So for objective lens everything is clear. For eyepiece lens, this object distance, right? For eyepiece, so this distance is given as UE. UE. Okay, eyepiece in the object, eyepiece in the E in the U not the objective. So UE. Okay, next one. Where the image will be formed? At here, far away distance. Okay, that distance I don't know. I am just not marking. So below, right? Focal length of the eyepiece lens is FE. I know this is called VE, you can say, or whatever it is. So focal length of the eyepiece lens is FE, and the object for eyepiece lens is at UE. Next we have to derive certain things. We are going to write something with respect to stuffs. Okay. First one. Length of the microscope in the length of the microscope. Length of the microscope is a tube in the length. A tube means eyepiece lens is very closer to your eye. Objective lens is very closer to your object. So what is the length of the tube? V0 plus UE. So length L equal to magnitude of V0 plus magnitude of UE. Length positive, length negative. Okay, UE. So V0 plus UE is the length of the microscope. 1 point. Second one, we are going to enter into magnification. Before that, what is beta? Beta from the figure. A dash B dash height tan alpha or tan beta. We'll say like tan beta. So tan beta. Beta is approximately equal to tan beta. What is this one? A dash opposite side by adjacent side. Adjacent side is means what? UE. So right. Tan beta or beta equal to A dash B dash divided by UE. We'll keep it there. We need something to express it. Below, right? For an eyepiece lens, magnification M equal to height of image by height of object. Correct? Magnification, height of image by height of object. Eyepiece for an objective lens, not for an eyepiece lens, for an objective lens. Writing mistakes. For an objective lens, height of image by height of object. What is height of image? Objective lens ആണ്, eyepiece അല്ല. A dash B dash ഇത് inverted ആണ്, so അത് negative ആണ്. Next one is object is straight AB, so I'm writing as minus of A dash B dash divided by AB. This I know the magnification, height of image by height of object. Magnification already we have another equation also, right? What is that? V by U for lens. For mirror, minus V by U. So V by U. So what is V? V is V naught. Correct? V naught positive or negative? Positive. Same direction of incident ray. So it is V naught divided by U naught. U naught is what? Negative, left side. So minus U naught. These two are equal, right? Both are magnification. These two are equal. So I'm writing as A dash B dash divided by AB is equal to V0 by minus U naught. Okay. So I'm writing minus cancel. A dash B dash is equal to what? V naught by U naught into AB. V naught by U naught into AB. Okay. Balance I'm writing on top of this one. Okay. V naught by U naught into. What is called AB? AB is the height of object. Height of the object. So we are replacing A dash B dash is equal to V0 by U0 into height of object. Now I am going back to beta. What is beta? We already written A dash B dash divided by UE. Correct? A dash B dash ne badala we will substitute A dash B dash divided by UE. Already we know. Here we will substitute this. So what will get? V0 divided by U0 UE into H naught. Okay, let me keep this some more time. So this is clear, right? Next one, what is alpha for simple and compound microscope? H naught by D. H naught by D. Okay, this is clear. Okay, next one, what we need to do? Magnification. M equal to what? Beta by alpha. Beta means V naught H naught U0 UE whole divided by H naught by D. H naught by capital D. So H naught cancel. So what all things will come? V naught by U naught. V naught by U. D will go to numerator into D by UE. V naught by U naught into D by UE. What is V naught by U naught? While looking there, it's a magnification of objective lens. Correct alla? V naught by U naught. What is D by UE? We already learned D by U naught. Correct alla? We already learned D by U naught because there is only one lens. This is what is called magnification of the simple microscope, which means magnification of eyepiece lens. We learned just before we learned D by U0. D by U0 is the, look into the notebook. We have learned for simple microscope D by U0. D by U0. D by U0 means what? Magnification of a simple microscope. There is only one lens. So their simple microscope na irikana lens aanu ivide irikana enna lens eyepiece lens ku equal aanu adukana U0 ku vare UE nu ezhudanathu. So this is a simple microscope, or I can say magnification of eyepiece lens. This is what? Simply magnification of objective lens. So this formula you can written as equal to M equal to magnification of objective lens multiplied with magnification of eyepiece lens. Then we'll go again with the two heading. Conditions for maximum magnification. Condition for maximum magnification. Condition for maximum magnification. Condition for maximum magnification. Okay, here we have two parts, right? In order to get maximum magnification, V0 by U0. This is what? Magnification of the objective lens. D by UE is for which one? Eyepiece lens, or we can say simple microscope. For simple microscope, what is the condition for maximum magnification? 1 plus D by F. So which means if I want to get a maximum magnification for a compound microscope also, V0 by U0 this D by UE. If this D by U is a simple microscope, so here also to get maximum magnification. Maximum magnification means strained eye or laxed eye? Strained eye. For strained eye, so again maximum magnification equal to V naught by U naught into simple microscope in a maximum substitute here. Simple microscope maximum, compound microscope maximum. What is the simple microscope maximum? D by F we have written. Here instead of F, what will come? FE. So 1 plus D by FE. 1 plus D by FE. Minimum conditions for minimum magnification, which means for a relaxed eye. Conditions for minimum magnification for a relaxed minimum magnification. Minimum magnification. This is also called a relaxed eye, right? This is what we learned. Relaxed eye. Relaxed eye. So for relaxed eye, what will be the formula will come? V0 by U0 into the minimum. Minimum means what? D by FE. Conditions for minimum. So at this point of time, we have to write in one additional point. We have written the length of the microscope or length of the tube. What we have written previously? V0 by UE. So instead of UE, now what will be there? FE. The V0 by U0 into D by UE, that's a general formula. In case of a relaxed eye or minimum magnification, what will get? UE, what is coming? FE. So the length of the microscope is V0 plus FE. So minimum magnitude വരുമ്പോൾ ലെങ്ത്തിന്റെ ഫോർമുല ചേഞ്ച് ആവും. Understood? Simple microscope, compound microscope. Appo we'll write a summary as like simple microscope. We'll write a summary. What we have written for a compound simple conditions for maximum and conditions for minimum. Maximum conditions, minimum conditions. Maximum conditions V0 by U0 into 1 plus D by FE. Objective lens edukka eyepiece lens aanu. Okay, so V0 by U0 into D by FE. Correct alla Sudarshan? No. Okay. So the magnifications value V0 by U0 less than or equal to, not correct alla oru term kodundalla, D by FE greater than or equal to, magnifications greater than or equal to V0 by U0 into 1 plus D by FE. Okay, we'll do one question problem. So right, in a compound microscope, once you have written this one, write a question. In a compound microscope, focal length of the objective lens is, in a compound microscope, focal length of the objective lens is 1.2 centimeter and focal length of the eyepiece lens is 3 centimeter. Okay, when the object is kept at 1.25 centimeter, when the object is kept at 1.25 centimeter in front of objective lens, then the final image formed at infinity, magnifying power of the microscope is dash. This is the 2018 Neet question. Magnifying power of the microscope is dash. The previous Neet question. So we'll analyze it. What are the things which are given to us? I will read the question once again. In a compound microscope, focal length of the objective lens is 1.2 centimeter. Focal length of the eyepiece lens is 3 centimeter. When the object is kept at 1.25 centimeter in front of the objective lens, final image is formed at infinity. Magnifying power of the microscope is. Okay, we'll list what are the things which are given to us. Focal length of the objective lens means f0. F0 equal to 1.2 centimeter. F0 or F0 equal to 1.2 centimeter. Eyepiece lens FE equal to 3 centimeter. F0 we got F0, we got FE. Next one, object is placed at, so U0 equal to how much? Minus 1.25 sign it answer is substitute easy. 1.25 image is at where? Infinity. Image infinity in the clue anna. Image infinity relaxed eye. For an strained eye, image will be where at least distance of distinct vision. Image is at infinity in for a which condition? For a relaxed eye. This is 3 hours. Okay. that's strike avanam. That's important. So, which means this is the conditions for possible right. Image at infinity is a conditions for relaxed eye. Condition kodutho heading kettu. Nama heading edi condition edi. That's the difference. Okay. So what will be the formula first of all? M equal to magnification V naught by U naught into D by FE. What all the things are given to us? Capital D is given up? Not given, but we can substitute 25 centimeters. FE is given in the question. U naught is given in the question. What we need? V naught. How we will find? 1 by F is equal to 1 by V0 minus 1 by U0 blah 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 blah. Then do it and tell me the answer. If you strike aina adu avladha. Nothing else. Simple. 4 marks basket lu vidum. Okay. You can tell me the answer. I can give you 4 options: 100, 200, 300, 400. 200
forms an image. Screen half hour sir. Apo blurred image sir form agudhu. Pixels kammi agudana sir, rays kammi agudana.
One concave mirror forms an image of an object on a screen if the lower half of the screen is no eppadi is opaque and the image is less bright ஆയിരിக்கும். blurred ஆகாது. மேலே கூட எப்படி நம்ம blurred focus சேஞ்ச் ஆகல blurred ஆக கீழே ஹைட் பண்ணினா ஃபோக்கஸ் சேஞ்ச் ஆகாதுன்னா நம்ம எதுக்கு நம்ம லென்ஸ் வச்சுட்டு கரெக்டாக ஃபோக்கஸ் பண்ண முடியலன்னு நினச்சது ஃபோக்கஸ் கரெக்ட் ஆக்கிறதுக்கு தான் இதில் ஃபோக்கஸ்ன்னு பிரச்சனையே இல்லை ஃபோக்கஸ் பிரச்சனை வருமா അതിൻ്റെ സർഫസിന് അബറേഷൻസ് വരും അബറേഷൻ ടോപ്പിക് പക്ഷേ அதுக்கு டிஃபெக்ட் வருமா இதுக்கு டிஃபெக்ட் இல்லை ஃபோக்கஸ் சேஞ்ச் ஆகல ஒரு பாட்டு கட் பண்ணி அவ்வளோதான் இப்போ இமேஜ் டல் ஆகும் மீன் blurred ஆகுது ஃபோக்கஸ் சேஞ்ச் ചെയ്യുമ്പോൾ நம்ம லென்ஸுக்கெல்லாம் അങ്ങനെ അഡ്ജസ്റ്റ് ചെയ്യില്ല ഫോക്കസ് അത് ഫോക്കസാണ് ഫോക്കസ് അഡ്ജസ്റ്റ് ചെയ്യാൻ சொல்ல சுதர்ஷன் ஆன்சர் சொல்லுங்க கரெக்டா நீங்க தான் ஃபர்ஸ்ட் சொல்லணும் தேவம் ரொம்ப நீட்டா இதுங்க கஜகஜா எழுதக்கூடாது தர்ணி சொல்லுங்க தர்ணி ஆன்சரு பிரீதா கட்சிங்களா இங்கே டூயிங் ஓகே சொல்லுங்க ஸ்டெரிக் டக்கு பண்ணுங்க 1.20 அங்கே 10 எடுக்க 1.2 தானே அப்போ மேலே 10 கீழே 10 வச்சு மல்டிப்ளை பண்ணி 10/12 வரீங்களா 10/12 வரும்போது 5/6 அப்போ ஃப்ராக்ஷனா ஈஸி இது வந்து யோசிக்கிறதுக்கு டைம் இல்லை டக்கு போகணும் 200 மைனஸ் உங்களுக்கு என்ன வேல்யூ கிடைச்சு 200 அவ்வளோதான் என்ன கிடைச்சோ அதுதான் ஆன்சர் தட்ஸ் ஆல் what you get that will be the answer what you get minus 200 okay minus 30 v not 30 pakata nanga inke answer gadichu v not 30 no okay
അത് U0 minus 1.2.
V0 30 എന്ന് വന്നു.
U0 minus 1.2.
U0 minus 1.25. ഓക്കെ.
D 25.
25 30. ഓക്കെ. അപ്പോൾ മാഗ്നിഫിക്കേഷൻ നെഗറ്റീവ് ആവാൻ കിട്ടുന്ന അതിൻ്റെ മീനിങ് എന്നാ? കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിൽ ഫോം ആവുന്ന ഇമേജ് ഇൻവേർട്ടഡ് ആണെന്നുള്ളതാണ്. അவ்வளோதான். മൈനസ് ഇരുന്നിനാ മൈനസിൻ്റെ മീനിങ് എന്നാ? ഇൻവേർട്ടഡ് ഇമേജ് ആണ്. കറക്റ്റ് അല്ലേ? ഒബ്ജക്റ്റ് വെച്ചിട്ട് ഫൈനൽ ഇമേജ് വരുന്നപ്പടി ഇൻവേർട്ടഡ്. ഇപ്പോൾ ഇൻവേർട്ടഡ് എന്നുള്ളതാണ് അതിൻ്റെ മീനിങ്, നത്തിങ് എൽസ്. മാഗ്നിഫിക്കേഷൻ എவ்வளோ മാഗ്നിഫൈ பண்ணி 200 ടൈംസ് മാഗ്നിഫൈ பண்ணி ബട്ട് ഇറ്റ് ഈസ് ആൻ ഇൻവേർട്ടഡ് ഇമേജ്. അപ്പോൾ 200 ആൻസർ എഴുതുന്ന 200 കൊടുത്തിടണം. -200 + 200 കൂടി അവർ തരാതെ 200 தான் തരും. അപ്പോൾ 200 പിക്ക് ചെയ്യുക. ബട്ട് உங்களுக்கு അതിൻ്റെ മീനിങ് എന്നാ? ഇറ്റ്സ് ആൻ ഇൻവേർട്ടഡ് ഇമേജ്. ഓക്കെ, മൈനസ് വന്നിനാ അതിൻ്റെ മീനിങ് ഇൻവേർട്ടഡ് എന്നാ, വേറെ മീനിങ് ഒന്നുമില്ലല്ലോ. കറക്റ്റല്ലേ? അടുത്ത ക്വസ്റ്റ്യൻ പോകാം. Finished, everybody? Shakti Ganesh finished. ഇതിന്മേൽ ഒന്ന് ഹെൽപ്പ് ഉണ്ടെങ്കിലാ കിടച്ചെങ്കിലാടാ. ഫൈനലി സ്റ്റെപ്പെല്ലാം എഴുതിട്ട് ഈക്വൽ ടു 200 എഴുതാൻ முடியாது. സിംപ്ലിഫൈ பண்ணி 200 എഴുതണം. ஓகே, கிடச்சுன்னா ஓகே, அவ்வளோதான். ஸ்டெப்பு மிஸ்டேக்காக இருக்கும் வேல்யூஸ் வரும்போது தான். என்ன ஐஸ்வர்யா கிடைக்கல? ஓகே. Finished, then we'll go to the next question. I'm waiting for you. ഈ 1.25 வந்து இது மாதிரி இடக்கூடாது. இப்போ இங்கே பாருங்க 1/1.2 10 വെച്ച് മേലെ മൾട്ടിപ്ലൈ 10 വെച്ച് കീഴே മൾട്ടിപ്ലൈ. അപ്പോൾ 10/12 എന്ന് വരും. അപ്പോൾ അതിനെ എപ്പടി പോടാം? 5/6 എന്ന് പോടാം. 1.25 വരുന്നോട്ടെ 100 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യാം. 100/125 5 വെച്ച് കട്ട് பண்ண കറക്റ്റല്ലേ? 20 ഡിവൈഡഡ് ബൈ എவ்வளோ വരും? 25 എന്ന് വരും. അപ്പോൾ ഈസി അല്ലേ? 4/5 കട്ടായി. ஏன்னா ஃப்ராக்ஷன் கீப் அப் பண்ண முடியாது. இப்போ ஜஸ்ட் ஒன் இன்ஃபர்மேஷன். இப்போ 1/1.5 எல்லாம் வரும்போது மேல മൾട്ടിപ്ലൈ പോത് 100 ഡിവൈഡഡ് ബൈ 125 വരും. 5 വെച്ച് കട്ട് ചെയ്യാം. 5 വെച്ച് കട്ട് ചെയ്യുമ്പോൾ എவ்வளோ വരും? 20 ഡിവൈഡഡ് ബൈ എவ்வளோ വരും? 25 വരും. 20 ഡിവൈഡ് ബൈ 25 എഗെയിൻ 5 വെച്ച് കട്ട് പണിയാ 4/5. അപ്പോൾ സിംപ്ലിഫൈ ചെയ്തത് ഈസിയാണ്. ഓക്കെ, നോർമലി ഇൻ യുവർ 1.25 into 1.2 divided by 1. So blah 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 means ടൈം ഇല്ലല്ലോ. അതുകൊണ്ട് ഫ്രാക്ഷൻ എപ്പോഴും സിംപ്ലിഫൈ ചെയ്യണം. ഓക്കെ, സിംപ്ലിഫൈഡ് ഫോർമുലേറ്റ് ആകുമ്പോൾ ഈസിയാണ് ആൻസർ. കട്ടായി പോയിട്ട് ഇപ്പോൾ എപ്പോൾ ഫ്രാക്ഷൻ വരെങ്കിലും അതിനെ 10 വെച്ചോ 100 വെച്ചോ മേലെ കീഴിൽ മൾട്ടിപ്ലൈ ചെയ്യണം. ന്യൂമറേറ്റർ ഡിനോമിനേറ്റർ. സോ ഇറ്റ് വിൽ ഗെറ്റ് സോൾവ്ഡ് ഔട്ട്. Next question. കിടക്കാത്തവർ കുറച്ച് സ്പേസ് വിടുക. Then try again. If not getting, come to me. Okay. Next question. A compound microscope consists of ഒരു ഹാഫ് പേജ് വിട്ടിനാ പോതാ. അவ்வளோதான். ഇപ്പം ഇൻ കേസ് ഇഫ് യു നോട്ട് ഗെറ്റിംഗ് ആൻസർ ഒരു ഹാഫ് പേജ് വിട്ടിട്ട് ബാലൻസ് എഴുതുക. ഓക്കെ. എ കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ് കൺസിസ്റ്റ് ഓഫ് ഒബ്ജക്റ്റീവ് ലെൻസ് ഓഫ് ഫോക്കൽ ലെങ്ത്. Objective lens of focal length 2 cm and eyepiece lens of focal length is 6.25 cm. Objective lens of focal length 2 cm, eyepiece lens of focal length 6.25 cm. Length of the microscope is 15 cm. 15 cm. Length of the microscope is 15 cm. How far from the objective How far from the objective lens should an object be placed? How far from the objective lens should an object is placed in order to obtain final image at? In order to obtain final image at least distance of distinct vision. In order to obtain final image at least distance of distinct vision. Also calculate the magnifying power. Additional one question, bonus from me. Also calculate the this is not there in the question. Also calculate the magnifying power. So what is given in the question? F naught. Okay, F naught, objective lens. The focal length ever question 2 cm. Eyepiece lens in the focal length FE equal to 6.25 cm given. What else is given? Length of the microscope capital L equal to 15 cm is also given. Okay, so L means what? Standard value of L V0 plus UE. V0 plus UE. That's the inference. 15 centimeters will be given. Image is at the least distance of distinct vision means maximum magnification or minimum? Maximum magnification. So what's the formula? M equal to V naught by U naught into 1 plus D by FE. And D in the value unde 25 centimeter. FE the value unde V naught illa U naught illa. But L is given. L is given. അപ്പം എല്ലിൻ്റെ വാല്യൂ ഉണ്ട്. വി നീഡ് ടു ഫൈൻഡ് ഔട്ട് വി നോട്ട് കണ്ടുപിടിക്കാം. ബട്ട് യു ഇ എപ്പടി കണ്ടുപിടിക്കാം? Think and do it. Anyway, you know, right? You can think. You think. You try. If you are not getting, I will help you. So these are the things which are given to you. You need to find out. അതിൽ ഐപീസ് ലെൻസിന് ഇപ്പം ഒരിൻ്റെല്ലേ ഇപ്പം ഇമേജ് ഈസ് ഫോംഡ് വെയർ? ഇമേജ് ഈസ് ഫോംഡ് അറ്റ് ലീസ്റ്റ് ഡിസ്റ്റൻസ് ഓഫ് ഡിസ്റ്റിങ്ക്ട് വിഷൻ മീൻസ് ഫൈനൽ ഇമേജ് ആണ്. ആ ഫൈനൽ ഇമേജ് ഈസ് ഫോംഡ്. ഓക്കെ, വൺ മോർ ഹിന്റ് ഐ വിൽ ഗിവ്. ഇഫ് ദ ഫൈനൽ ഇമേജ് ഈസ് ഫോംഡ് അറ്റ് ലീസ്റ്റ് ഡിസ്റ്റൻസ് ഓഫ് ഡിസ്റ്റിങ്ക്ട് വിഷൻ சொல்லும்போது capital D is equal to 25 centimeter. But there the value of final image is final image is formed at the least distance of distinct vision means final image is at 25 centimeter. Can I say like that? Okay, final image is at 25 centimeter. Final image is formed by which lens? Objective ആണോ eyepiece ആണോ? eyepiece അല്ലേ. ഫസ്റ്റ് ഒബ്ജക്റ്റീവ് ഇമേജ് ഉണ്ടാക്കും, ഇമേജ് കൊടുക്കും. സോ ആ കേസിൽ ഫൈനൽ ഇമേജ് VE eyepiece in the image VE is equal to 25 centimeters. അതൊരു ഹിന്റ് ആണ്. You got my point? Now can you tell me before going to answer, can you tell me what all the things are given in the question? F naught is given, FE is given, capital L is given. L I know, V0 plus UE magnitude ആണ് രണ്ടും. Okay, കാരണം ലെങ്ത് പോസിറ്റീവ് അല്ലേ വരുന്നത്. സോ വി നോട്ട് പ്ലസ് യു ഇ കീപ് ഇറ്റ് ദർ. അവിടെ യു ഇക്കും വി നോട്ടിനുള്ള സൈൻ കൺവെൻഷൻസ് അപ്ലൈ കൊണ്ടക്കൂടാതെ ബിക്കോസ് ഇറ്റ് ഈസ് മാഗ്നിറ്റ്യൂഡ് ലെങ്ത്. ഓക്കെ, നെക്സ്റ്റ് വാട്ട് ഈസ് അഡീഷണൽ തിങ്? ഈ ഫൈനൽ ഇമേജ് ഫോംഡ് അറ്റ് ലീസ്റ്റ് ഡിസ്റ്റൻസ് ഓഫ് ഡിസ്റ്റിങ്ക്ട് വിഷൻ. ആ സ്റ്റേറ്റ്മെന്റിന്റെ ഇൻഫറൻസ് എന്നാ? ഫൈനൽ ഇമേജ് ഫോംഡ് അറ്റ് D at a distance of D. I know that is a condition for maximum magnification. So final image is formed at D means final image formed at 25 centimeter. Who create the final image? Eyepiece lens. So eyepiece lens in the final image in the distance in sollumbode VE is equal to plus 25 or minus 25? minus 25. அதெல்லாம் இம்பார்ட்டன்ட். ப்ளஸ் இட்டா அதே ஆப்ஷன் ஆன்சர்ல இருக்காங்க, அங்கே இருக்கும். அதை கேரி அடிச்சுன்னா போய் -1. அதெல்லாம் whatever the mistakes you will make they will know already, so they will place the options accordingly. അതാണ്. അപ്പോൾ F0 ഉണ്ട്, VE ഉണ്ട്. Next you can find out UE, right? UE you can find out from this one. 1 by FE equal to 1 by VE minus 1 by UE. Step by step will do. 1 by FE equal to, that's the first steps. 1 by FE equal to 1 by VE minus 1 by UE. We are applying lens makers formula. Oh hurry, will take time and do. Eyepiece lens ne nammal find first lens makers formula apply. Eyepiece lens ne 1 by FE equal to 1 by VE minus 1 by UE. Okay. Ini eyepiece lens inde focal length evlo 1 by 6.25, everything in centimeters. So 1 by VE, VE evlo minus 25. Correct? Minus 1 by UE. This is UE kandupidikkana. U in the value first solunga. Minus 5. So UE equal to minus 5. I don't know. Two people told, I written. That's all. UE minus 5 ആണ് ഫസ്റ്റ് കൺഫേം പണി. ഇതാണ് ഇതിന്റെ ഫസ്റ്റ് സ്റ്റെപ്പ്. ഓക്കെ, UE minus 15 centimeter. It's the first step. Minus 5 കടിച്ചില്ല everybody? I don't know, Jayasri told, I written. Is minus 5 first or you are doing? Minus 5. Adukappuram I am going to calculate length. Length equal to modulus V0 plus modulus UE. L equal to modulus V0, I don't know. What is modulus UE? 5. Length evlo 15, it's given, right? 15. So modulus V0 equal to 10. Modulus V0 equal to 10. So V0 value I got it 10. Okay. If modulus V0 equal to 10, you can also write V0 equal to 10. Plus or minus 10 options ഉണ്ട്, but we don't know how to decide. V0 is positive or negative? First of all, you tell me. See, modulus of V0 is plus 10. അപ്പോൾ V0 equal to plus 10 വരാം, minus 10 വരാം. But ഒരു compound microscope plus or minus V0? Plus, right? V0 means what? Image formed by the objective lens. Right side, positive അല്ലേ? So it's positive. So it is 100% positive. Be sure. For a compound microscope. For modulus V0 equal to 10 and V0 equal to plus 10 and V0 equal to minus 10 and but V0 equal to minus 10 options. Why? Because compound microscope will never form an image on the left side. Correct? Compound microscope in a diagram, if you look into eyepiece, objective lens will create an image on the right side. Positive V0 equal to 10. So I got V0. What is my next aim? U0 കണ്ടുപിടിക്കണം. U0 കണ്ടുപിടിക്കുന്നതിന് F0 is given. Yes, how much? 1.2 centimeters. Okay, 2 centimeters. So what we can do will be here. Lens makers formula. We'll apply lens makers formula. Again, based on this one, we'll apply. 1 by F equal to 1 by F0 equal to 1 by V0 minus 1 by U0. ഇതിൽ 1 by F0 2, 1 by V0 10 minus 1 by U0. ഇതിൽ U0 ന്റെ വാല്യൂ എവളോ? How much you got? Minus 2.5. Minus 2.5 എന്ന് ചൊല്ലുമ്പോൾ ഒബ്ജക്റ്റ് ലെഫ്റ്റിലാ റൈറ്റിലാ? ലെഫ്റ്റിൽ. കറക്റ്റ് അല്ലേ? അതല്ലേ കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിൽ. So first question is answered. Where should I have to place the object with respect to objective lens? Objective lens on the left side 2.5 centimeter distance I have to place the object. What is the bonus question I have given to you? Magnification. This is what type of magnification I have to apply? Maximum or minimum? Maximum. So we'll maximum. So maximum magnification formula is this one. M equal to V naught by U naught. V naught is how much? 10. U naught is how much? Minus 2.5 into 1 plus D. D is 25. Fe is how much? 6.25. 10 by 4 minus 4 25 by 6.25 and 4. So how much will come? 5 into 4 minus 20. Minus indicates what type of image? Inverted. Final image is inverted, right? In compound microscope. So the magnification is equal to 20. So short break, then we'll continue. Okay. 10 minutes, not more than that.
ஸோ அந்த டி வந்து 25 போட்டுக்கலாம், சைன்லாம் போட்டுக்காரு. டி இங்கே தான் டிஸ்டன்ஸ் எடுக்கிறோம்.
எதுக்கு
டி மைனஸ் 25 போடலாம்.
மைனஸ் 25 தானே எடுத்துருக்கണது.
எம் மேக்னிஃபைங் பார்ட் போடும்போது டி வந்து நம்ம ஐலேருந்து பார்க்குறோம் அப்படின்லாம் கணக்கு எடுக்காமல் ஜென்ரலாக 25 போட்டுக்கலாம்.
25 போடலாம். 25 ஸ்டாண்டர்ட். If you don't want break, we'll continue. You want or we'll continue? I'm okay. We'll continue. Then we'll finish it later. Maybe before 1 o'clock. Okay. We'll continue. Doubt? Okay, I'll come. If it is finished, then
இமேஜ் இந்த சைடு
yes.
அப்போ நெகட்டிவ் இருக்கும்.
ஏது இமேஜ்?
இது ஃபர்ஸ்ட் ஆப்ஜெக்டோட இமேஜ். அப்போ நம்ம அது நெகட்டிவ் எடுக்கக்கூடாது.
எடுக்கும். What is V naught? V naught is the distance from here, not this inverted. Inverted is the height of image. This height is negative. Distance negative. Distance from here to here, right? U naught opposite. This is instead, right? This is opposite on U naught. V naught is the direction. Height is negative. Distance negative. In the formula,
compound microscope
in the formula, this is minimum. The question is length of the tube for minimum magnification. General equation is V0 plus UV. Okay, then next write the heading. Telescope. Telescope will and finish. Then we have to start the next chapter, rotational motion. Tell me.
Sorry, we are taking DS. So here it should be minus. D should be minus.
Magnification formula is modulus D by F. Modulus D. Modulus one second. Many are asked the same doubt. That's what I want to repeat. Magnification formula V naught by UE into 1 plus D by FE. ഈ ഫോമിലല്ലേ ഇതിൽ ആക്ച്വലി എവറി ടേം ഈസ് മാഗ്നിഫിക്കേഷൻ ചൊല്ലുമ്പോൾ അത് 5 times സൂം ആയോ അല്ലെങ്കിൽ 10 times സൂം ആയോ അതിൻ്റെ ക്വാണ്ടിറ്റിയാണ്. ഓക്കെ എവ്വളോ അത് ഇൻവേർട്ടഡ് ആണോ നോൺ ഇൻവേർട്ടഡ് ആണോ ഓൾറെഡി വി നോ ഫ്രം ദ തിയറി. കോമൺ മൈക്രോസ്കോപ്പിൽ ഇൻവേർട്ടർ ആണ്, സിമ്പിൾ മൈക്രോസ്കോപ്പിൽ ഇൻവേർട്ടഡ് അല്ല. അതുകൊണ്ട് എവറി ടേം യു ക്യാൻ ടേക്ക് മോഡുലസ്. Every term you can take modulus because I need the value how much time it is zoomed. Why? Because people are asking, sir, this is negative, then this is negative. You don't want to bother about whether it is negative or positive. Magnification is the quantity, how for a microscope how much it is enlarged. Okay, so all are in terms of magnitude. In your formula you can make correct it in case if you have doubt. Everything in terms of modulus, because whether it is 3 times magnified, 4 times magnified only you want to say. You don't want whether it is inverted or non-inverted, that doesn't matter. Because microscopic theory itself it is saying whether it is inverted or non-inverted. You don't want to explicitly say that. Okay. Okay, we'll go. Telescope is a device. Write the next heading. Telescope. Next heading. Telescope. 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 Telescope is a device. You already seen telescope in your life, huh? From where? Huh? Sorry? Okay. Telescope is a device used to look distance object like a stars, planet is used to look distance object. Distance object. Okay. At least you've seen telescope in your life, huh? Okay, I'll ask one question. Telescope is used to zoom the image or not to zoom the image? Zoom means magnifying. No, telescope will not magnify. Okay, telescope is not magnifying the images. Magnifying is ഒരു ചിന്ന സന പെരുസാക്കി കാണിക്കാൻ. It's not magnifying. Telescopes will always see you the original size only. But what is the problem means its intention is to look for and to see for an object which is at larger distance. അപ്പോൾ ആ ഒരു ഡിസ്റ്റൻസിനെ ഷോർട്ട് ആക്കി തരും உங்களுக்கு. உங்களை லீஸ்ட் டிஸ்டன்ஸ் ஆஃப் டிஸ்டிங்க்ட் விஷனில் கொண்டு வந்து ஆப்ஜெக்டிനെ പ്ലേസ് ചെയ്യും. അത് மட்டும்தான் ടെലസ്കോപ്പ് ചെയ്യണം. ടെലസ്കോപ്സ് വിൽ നോട്ട് സൂം ഔട്ട്. ഓക്കെ, സൂമിങ് കേട്ടിനാ ഈ കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പും വേറെ ഇരിക്കുന്ന ഇലക്ട്രോണിക് മൈക്രോസ്കോപ്പ് ഒന്നും സൂം ചെയ്യണം അന്ത അളവുക്ക് സൂം ചെയ്യാതെ. അതാണ് சொல்றதுக்குള്ള റീസൺസ്. ആ ഒരു ഒബ്ജക്റ്റിനെ ഒരു കറക്റ്റ് പ്ലേസിൽ കൊണ്ടുവന്ന് വെച്ചിരും. ഓക്കെ, നോട്ട് ലൈക്ക് അതർ മൈക്രോസ്കോപ്പ്. അണ്ടർസ്റ്റുഡ്? ദെൻ telescope is consist of again two lenses. Telescope is consist of two lenses. One is objective lens having high focal length. Objective lenses having high focal length and eyepiece lenses having smaller focal length. What is the difference between the telescope and compound microscope? Compound microscope il objective chinnada irukum, smaller focus on objective ne, eyepiece ne bigger focal length. But in case of telescope nere reverse ആണ്. Objective is bigger, eyepiece is smaller. അതാണ് കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പും ടെലസ്കോപ്പും തമ്മിലുള്ള ഡിഫറൻസ്. Now we'll do the construction. Right, construction. How it's coming, the telescope. Objective is a bigger lens. Eyepiece is a smaller lens. One difference is like that. This is not a zooming lens. This zoom is used in a lens in a telescope. അതുകൊണ്ട് നമ്മൾ നോർമൽ കേസിലുള്ള വിഷ്വൽ ആംഗിൾ ആൽഫയുടെ ജനറൽ ഇക്വേഷൻസ് എടുക്കുന്നില്ല. h naught by d. h naught by d means object is where? At a distance of d. Here object is where? I don't know. It's very far away. Correct? Star and planet. അതുകൊണ്ട് ആ ആൽഫയുടെ വിഷ്വൽ ആംഗിൾ ആൽഫ എന്നുള്ള എക്സ്പ്രഷൻ is not applicable here. Write a note of this one. Here object is not at the least distance of distinct vision. Here object is not at the least distance of distinct vision. So standard equation of the visual angle So the standard equation of the visual angle alpha equal to h naught by d, not applicable, h naught by d not applicable here. H naught by d not applicable here. Okay, next let's see. Object is where? Infinity. I don't know. So this is my objective lens and this is my eyepiece lens. Okay, so object is at infinity. Object is at infinity means we will draw what type of lines? Parallel lines. If one ray is coming parallel to the principal focus, where it will passes? It will passes through the focus, for example. Okay, suppose I know this object is at infinity, so instead of doing parallel lines, I am just drawing some light rays are coming like this one. If another light rays are coming like this one, so what will happen? This is going through where? Optical center, for example. So what I'll got means I will get a very small image, size on the very small image, where it will, where should I will get the image? I will get an image at the focus. Focus of which lens? Focus of the objective lens. The focus level get an image. So here I know object is at infinity. Okay, object is at infinity, or I can say object at far away. At far away, object is at far away. It's very away distance, and this object and this distance is the image distance which is given as u0. But what is the condition? What is the condition here? It's like for the eyepiece lens, this image must fall between where and where? Must fall between optical center and focus of the eyepiece. Let me consider this is the focus of eyepiece. See, focus of eyepiece and middle image fall eyepiece. Which will fall? This objective lens will create an image will be here. Okay, as the rays are coming from infinity, the image is at focus, but this image will be definitely falls between and eyepiece in the focal length. So what will happen now? Now we have two rays, one is parallel to this one and this will goes where? Through focus. Next one is where? Next one is going through focus and it's a diverging lines, and if you are extending these two diverging lines, it will meet at some point, and this will create an image. Why I am saying it is not zooming means object is at very far away, but comparable to that the image is not very far away. So the object is very far away means I am not zooming the image. Actually my image is a diminished image only. If I am looking for star, what is the size of star? Too big. But comparable to that my image size is small only. So here the magnification value of the telescope is not that much higher as that of telescope. Shorter value. Actually whatever the size will be, that size will be coming to the distance in the short track. That's a telescope in a purpose. If you are looking from here for a star, you can see a dot. But if you look for a telescope, you can see the real star structure. That's the difference. If you look from here, you can see a dot, you can see a dot in the sky. But if you looking through a telescope, you can see the real beautiful star-like structure. That is the only difference. That is the only enhancement doing by the telescope. So again, telescope is using two lenses, objective lens and eyepiece lens, each having its own focus. Object is at infinity, image formed at focus, and this focus image is falling between optical center and eyepiece, and this will create a virtual inverted image. Magnification will be there definitely. If you are looking with your naked eye, you can see a dot. But if you look into a telescope, you can see the real structure. So it's a zooming, but it's not as like that of compound microscope. Understood? We'll draw the diagram. Then we have to derive an expression for alpha.
Here the parallel rays should pass through the focus.
ഇല്ല, ഒബ്ജക്റ്റ് ഫോംഡ് ഫോക്കസ് അല്ല, ഇത് പാരലൽ ആയിട്ട് വന്നതിനാல ഫോക്കസ് കൂടെ പാസ് ചെയ്യുക. ഇത് പിന്നെ പാരലൽ അല്ല എടുത്തിരിക്കണം. പാരലൽ മീൻസ് ഇപ്പോൾ നോട്ട്ബുക്ക് ഇല്ല പെൻസിൽ, അതായത് ഇതിൻ്റെ എയിം ഇത്രയേ ഉള്ളൂ. ഇതേമാതിരി നിറയെ റൈസ് വന്നിട്ടേ இருக்கும், ഇൻഫിനിറ്റ് തന്നെ ഒബ്ജക്റ്റ്. അപ്പോൾ ഇതേമാതിരി വരുന്നൊരു റേ ഇங்கே വന്ന് റിഫ്രാക്ഷൻസ് പോയിടും, റിഫ്രാക്ഷൻ എടുക്കും. ഇത് വന്ന് റിഫ്രാക്ഷൻ എടുക്കും. എപ്പോൾ ഇതിൽ പാരലൽ റൈസ് എടുക്കും, പാരലൽ റൈസ് വരുമ്പോൾ മറ്റൊന്ന് അത് ഫോക്കസ് കൂടെ പാസ് ചെയ്യണത്. ഈ വരുന്ന റൈസ് ഫോക്കസ് അല്ല, ബിക്കോസ് യുവർ ലെൻസ് ഈസ് എക്സ്പോസ്ഡ് ടു ദ ലൈറ്റ് കേട്ടോ. അപ്പോൾ എല്ലാ സൈഡിൽ നിന്ന് അതിലേക്ക് ലൈറ്റ് റൈസ് വരും. പാരലായിട്ട് വന്നാലാണ് അത് ഫോക്കസ് കൂടെ പോകുന്നത്. ഇത് പാരലായിട്ട് വരുന്ന ഒരു റൈസ് അല്ല, നമ്മൾ പാരലായിട്ട് നിങ്ങൾ പോയിട്ടുള്ളത് ഫോക്കസ് കൂടെ പാസ് ചെയ്യും. ബട്ട് ഫൈനൽ ഇമേജ് ചെല്ലുമ്പോൾ ഇത് എല്ലാം കൂടി മെർജ് ചെയ്യുന്നൊരു പോയിന്റ് ഇരിക്കും. ഓക്കെ, അതായത് ഫോർ എക്സാമ്പിൾ ഇങ്ങനെ ലേ വന്നു, ഫോക്കസ് കൂടെ പാസ് ചെയ്തു, ഫോർ എക്സാമ്പിൾ ഫോക്കസ് കൂടെ പാസ് ചെയ്തു. ഇനി വേറെ റേസ് വന്ന് ഒപ്റ്റിക്കൽ സെൻറ്റർ കൂടെ ഇങ്ങനെ പാസ് ചെയ്ത് പോകും, വേറെ റേസ് വന്നിട്ട് ഇങ്ങനെ കട്ടാവും. അപ്പോൾ ഇതെല്ലാം തന്നെ മീറ്റ് ചെയ്യുന്ന ഒരു കോമൺ പോയിന്റ്, സംവെയർ ഒരു കോമൺ പോയിന്റിൽ ഇത് മീറ്റ് ചെയ്യും. ആ മീറ്റിംഗ് പോയിന്റ് ആണ് ഒബ്ജക്റ്റീവിൻ്റെ ഇമേജ് എന്ന് വെച്ചിട്ടുണ്ട്. ഒബ്ജക്റ്റീവിൻ്റെ ഇമേജ് കാരണം ലൈറ്റ് ഇതിങ്ങനെ ഓപ്പൺ അല്ലേ, ആ ഒരു ലെൻസ് ഓപ്പൺ ആണ്. നിങ്ങൾ ടെലസ്കോപ്പ് നോക്കിയിട്ട് ഒരു ലോങ് പൈപ്പാണത്, അതിൻ്റെ ഔട്ടുള്ള ലെൻസ് ഇങ്ങനെ ഓപ്പൺ ആണ്. എല്ലാം യു ക്യാൻ ടേൺ അറൗണ്ട്. Okay, so draw this diagram. So below write objective lens will create an image. You are drawing. Okay, then first complete this one, then we'll write complete. Sorry. This optical instrument is not there for the coming model examinations. This is not there. Okay, up to optical instrument will be there. Next model will go, I'm sure. Next model, next unit test ആണ് വരുന്നത്. Okay. So finished up. Okay, so below write objective lens form an image, objective lens form an image, objective lens form an image between eyepiece lens optical center and eyepiece lens focus. Between eyepiece lens optical center and eyepiece lens focus. Between eyepiece lens optical center and eyepiece lens focus. This image is this image, yes correct, this image is act as object for which lens? Eyepiece lens. This image will act as object for eyepiece lens, and eyepiece lens forms the final image, and the eyepiece lens forms the final image. Next one, length of the telescope. Length of the telescope. Length of the telescope. What is the length of the telescope? This distance is UE. L equal to modulus of V0 plus modulus of UE. But in this case, what is V0? Modulus of F0. Modulus of F. This is at focus on point. Is in the focus. So plus modulus of UE. Very important. Very important. Very important. This will come as a question directly. Okay. F0 plus UE. Next one. Here I told before starting this topic, the general equation of alpha is not applicable here. Alpha is the visual angle made with respect to the object. That concept is correct, but H naught by D cannot use because I don't know where, at how far away from the object. So look into this diagram. So suppose I'm assuming object is here. So this visual angle is called alpha. Visual angle is called alpha. Suppose object is here, so this visual angle is called alpha. This is equal to this one, right? Opposite angles are equal. So this is equal to this one. Now can you tell me what is alpha? Let me consider this like A dash B dash. So what is alpha? Tan alpha, okay, tan alpha equal to dash B dash divided by F naught. Correct? A dash B dash B dash divided by F naught. F naught and V naught equal to F naught. Both are same. So right, tan alpha is equal to, first length equation is tan alpha equal to A dash B divided by F naught. Okay, alpha diagram mark idum equal. Okay, next one. What is beta? Beta is the angle subtended by the image with eye. With eye means eye lens. This angle is called beta. Can you tell me what is beta from here? Tan beta. Tan beta equal to A dash B dash divided by UE. Good. Tan beta is equal to beta. I know. So magnification M equal to beta by alpha, which is equal to A dash B dash divided by, correct, A dash B dash divided by UE whole divided by A dash B dash divided by F naught. So magnification equal to F naught by UE, general equation, important. Telescope is important. Telescope le questions varunda. F naught by UE. Okay, next we want to derive an expression for high magnification or maximum magnification and minimum magnification. In case of a simple microscope, this part is again similar to what? Our simple microscope only. In case of a simple microscope, how we derived an expression for maximum magnification? Maximum magnification means V, image is formed at where? Least distance of distinct visions. Correct? The same cases we are going to apply will be here. So below, right? For maximum magnifications, first one. For maximum magnification. For maximum magnification, we require concentrations to the eyepiece lens only. U equal to minus UE. Object is equal to objective distance. U is equal to minus UE. Where should the image has to be formed? For a maximum magnification, I am using, okay, let me take it, okay. UE will be there. UE is what? Negative value. UE is negative. So UE is negative. And V is equal to what? V is equal to, or VE is equal to what? Minus D. V is equal to minus D. Then we'll apply the formula and we'll see. So focal length of the eyepiece FE equal to, tell me, lens formula 1 by VE minus 1 by UE. So 1 by FE is equal to 1 by V, 1 by minus D, minus 1 by UE. UE means minus UE. Okay, substitute 1 by FE equal to minus 1 by D plus 1 by UE. Okay, so 1 by UE is equal to 1 by FE plus 1 by D. 1 by D. So what is 1 by U? Now I can substitute here magnification equal to F naught by 1 by U ik badala F naught into 1 by FE plus 1 by D. F naught ulla multiply edina we'll get F naught by FE into F naught by D. Conditions for maximum magnification. F naught by Fe plus F naught divided by D. This is the condition for maximum magnification. F naught and Fe you know, right? F naught means what? So condition for maximum magnification means strained eye. Next one, next heading for minimum magnification. 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 For minimum magnification, object is formed where? Sorry, object is at UE. Object is at UE. Image is at where? Infinity. So the next one, for minimum magnification. For minimum magnification, second one. For minimum magnification. For minimum magnifications, it is minus UE and V is equal to minus infinity and Fe is also there. We'll substitute in the formula 1 by Fe is equal to 1 by VE minus 1 by UE. 1 by Fe same is equal to 1 by VE. VE means what? 1 by minus infinity and minus 1 by minus UE. So what I'll get? 1 by Fe is equal to 1 by UE. So the magnification formula what we got? F naught by UE. So magnification M equal to F naught by Fe. Minimum magnification. Clear? Summary. Telescope, maximum magnification and minimum magnification. Tell me, maximum means what? I forgot the formula. Tell me, what is maximum? D. This is called M. Minimum magnification. First term is equal to M. Which means F naught by Fe greater than or equal to M greater than or equal to F naught by Fe plus D by Fe. All this formula has to written on your formula book. F naught by D. All this formula you have to written on your formula book. Okay, because many things will be there. Next, write a question. A refracting telescope. This is called a refracting telescope. A refracting telescope is under normal adjustment. Under normal adjustment, the magnifying power is 5. Under normal adjustment, magnifying power is 5. Number 5. If the length of the telescope under this condition If the length of the telescope under this condition within a bracket right, within open a bracket and right, when the final image is at infinity, final image is at infinity. Break വേണ്ടത് ജസ്റ്റ് ഒന്ന് കട്ട് ചെയ്തിട്ട് എടുക്കണം പോകും. ജസ്റ്റ് ഒന്ന് ഓഫ് പണിയിട്ട് തിരിച്ചു വന്നിട്ടുണ്ടല്ലോ. You want break? If you want break, I can give you. Else we'll continue. So, last thing about that. If the length, okay, if the length of the telescope under this condition within a bracket we have written, when the final image is at infinity, close the bracket and then continue, is 150 centimeter, is 150 centimeter. Find f0 and fe. Find f0 and fe. Length of the telescope is what? 150 centimeter. What is the equations for length? f0 plus ue. f0 plus ue. So when the image is at infinity means, first thing and then right. Image is at infinity means minimum magnification, maximum magnification. Minimum magnification. Minimum magnification general formula is what? f0 by ue. For minimum magnification, what we will get? f0 by fe. f0 by fe. So what is the length of the telescope we have written? f0 plus ue. So I know image is at infinity. Okay. So what will be the length? Already I know that formula for length is equal to f0 plus ue. This is what we written, right? For minimum magnification, m is equal to f0 divided by u is a general equation. But when m is m minimum, what we will get? f0 by fe. So ue is replaced with what? fe. So in this case, what will be the length? Length equal to f0 plus fe. f0 plus fe. So length is given in the question. How much it is? I think it 150, yeah? 150 centimeter. What are the other things are given? Normal adjustment, the magnifying power. M is given. M is given will be here. M is given as 5. So two conditions, two equation you can form, right? 5 equal to f0 by fe. So 5 equal to f0 by fe. Equation number 1. 150 equal to 150 equal to f0 plus fe. Anyway, both are convex lenses, so both focal length are positive. So this is equation number 2. This two equation solve. Then you have to find what is f0 and what is the other things. What's the answer? Which one 25? Fe? Fe equal to 25. F0 equal to 125. Perfect. Next question. Next, finished. Both values f equal to 25, f0 equal to 125. The next one, the focal length of the objective lens of refracting telescope. The focal length of the objective lens of the refracting telescope is 100 centimeter. Is 100 centimeter. And that of eyepiece is 5 centimeter. Eyepiece is 5 centimeter. If the final image is formed at least distance of distinct vision within bracket capital D equal to 20 centimeter. Sometimes they will give you the value, sometimes they will not give you the value. Whatever they are given, you take it. If not given, you take it 25 granted. Okay, next one. Find the magnifying power of the telescope. Find the magnifying power of the telescope. Previous NEET question. Bonus question from me. Find the length of the telescope. Okay. ഇതെല്ലാം മോഡൽ എക്സാംസ് വരും നെക്സ്റ്റ് ടൈം. അപ്പോൾ you have to answer. Okay, we will answer first. What all things are given, we have to mark it first. Okay, final image is formed at where? At least distance of distinct vision. Final image will be formed by objective or eyepiece. So VE is equal to how much will come? Minus 25. Correct alla? Correct. Next one, UE, where the UE is formed, that I don't know. So UE will keep it as such. Next one, eyepiece in the focal length, which is given? No, it's not given. Okay, 5 length. So FE equal to plus 5 centimeter. Next, what other things are given? Objective in the focal length is given. F0 equal to 100 centimeter. Okay, so next question is what? We have to find out the magnifying power. So magnifying power equation is what? Maximum. F0 is given, F is given, F0 is given, D is given. You can substitute, answer ready. 5 marks. 4 marks. சொல்லுங்க. 24. Magnifying power 24 correct answer ആണ്. Magnifying power 24. If you substitute everything, will be here. Very simple, right? This is what we are always telling. NEET examination is simple. F0 by FE, F0 by D equal to M. 24 எடுத்துட்டோம். கரெக்ட்டுங்களா? புரியுதா? இனி next length of the telescope எவ்வளோ? What is the formula for length? Maximum conditions വരുമോ? Minimum conditions വരുമോ length ന്റെ formula എന്നാ? F0 plus FE എന്ന് വരും. F0 plus FE എന്ന് വരും. ഇതിപ്പോൾ മിനിമം കണ്ടീഷൻ അല്ല, ബട്ട് ഇറ്റ്സ് എ മാക്സിമം കണ്ടീഷൻ. മാക്സിമം കണ്ടീഷനോ അല്ലെങ്കിൽ ജനറൽ കണ്ടീഷനോ വരുമ്പോൾ വാട്ട് വിൽ ബി ദ ഫോർമുല ഫോർ ലെങ്ത്? ലെങ്ത് ഇസ് ഈക്വൽ ടു F0 plus UE. അതിൽ UE കണ്ടുപിടിക്കണം. UE കണ്ടുപിടിക്കുന്നതിന് ഹിന്റ് ഈസ് ഗിവൺ ഇൻ ദ ക്വസ്റ്റ്യൻ. ഹൗ ടു ഫൈൻഡ് ഔട്ട് UE? 1 by F is equal to 1 by VE minus 1 by UE. VE is given. VE is equal to minus 25. FE is given in the question. UE കണ്ടുപിടിക്കണം, സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യണം, ലെങ്ത് കണ്ടുപിടിക്കണം. അவ்வளோதான். not 6 24. Not 4 or not 6 something or not something. Okay, or not 4 or not 6. Okay, whatever it is. Or not 6 or not 4. Okay, so not 4. But telescope over, but microscope over, simple microscope over, compound microscope over, telescope over. Okay. Then we will just summarize. the points. Three microscope we learned, right? Simple microscope, compound microscope, telescope. I will ask the question, you will answer the question. Simple microscope in evolo lens unde? Only one. That lens is equal to eyepiece lens. Okay. Simple microscope in a magnification formula. General formula. D by UE or U naught. U naught is UE. U naught is UE for objective. Whatever lens is UO. Okay. Maximum magnification formula 1 plus D by F. Minimum magnification D by F. This is a minimum case. Next one, compound microscope. General formula for magnification. Compound microscope. Compound microscope D by U naught. Magnification. Look into the book. I am sure you will not remember. Compound microscope in the magnification formula D by U naught. I don't know. V naught by U naught into D by U naught. First simple microscope. Simple microscope D by U naught. That is D by eyepiece equal. So D by U in. So one compound microscope two lenses. Objective lens and eyepiece. Two magnification straight multiply. V0 by U0 into simple microscope. D by U. That is easier. D by UE. In our case, two conditions, maximum, minimum, strained eye or laxed eye. Strained eye image is at where? Least distance of distinct vision from where? Eyepiece lens. Now, in the formula now, V0 by U0 into 1 plus D by FE. And our D by FE is part of simple microscope. Minimum magnifications V0 by U0 into D by FE. Minimum magnifications or maximum magnifications. Which of the following statement is true? I'll tell you 4 statements. You have to tell me which statement is true. Okay. Simple microscope consists of one lens. True. Focal length of the objective lens is higher than focal length of the eyepiece lens in compound microscope. False. That is true for which one? Telescope. Karana, important first lens bigger telescope. Okay, compound microscope is objective lens compound eyepiece lens normal compound microscope. Telescope this one. Telescope is a zoomed lens. False. Telescope is not zooming. Telescope is giving a clear picture. Zooming in but not like that of common microscopes. Okay. Length of the compound microscope is V0 plus UE. V0 plus UE. In case of a minimum magnification, length of the compound microscope is V0 plus FE. I use it on multi FE. In case of a telescope in the length general formula V0 plus UE. That is V0 plus UE. But that is V0 first of all. V0 is F0. V0 F0. F0 plus UE in minimum magnification F0 plus FE. Formulas combinations. I will ask compound microscope in a minimum magnification condition. Compound microscope minimum magnification condition length of the microscope. Formula compound microscope minimum magnification formula V naught by U naught into D by FE. That is the length of the microscope. V naught plus FE. V naught plus FE. You can look into your notebook. You don't want to think from the air because just 5 minutes before only you learned, right? So it's very hard to remember. Naraya formulas in there. Once you revise it, it will come to your mind. So simple microscope whatever lens compound microscope two lens two magnifications multiply. Left side V0 by U0 fixed ആണ്. അതേ multiplied with simple microscope. Simple microscope D by F വരാം ഇല്ലனா 1 plus D by F വരാം. F ക്ക് ബദലായി ഇങ്ങ എന്നാ പോടും FE എന്ന് പോടും. അതാണ് ടെലസ്കോപ്പിന്റെ മാഗ്നിഫിക്കേഷന്റെ ഫോർമുല എന്നാ? ഗോ ടു ടെലസ്കോപ്പിന്റെ മാഗ്നിഫിക്കേഷന്റെ ഫോർമുല എന്നാ? ടെലിസ്കോപ്പിന്റെ മാഗ്നിഫിക്കേഷന്റെ ജനറൽ ഫോർമുല എന്നാ f0 ഡിവൈഡഡ് ബൈ UE. അത് ഫസ്റ്റ് തരണം, അതൊരു ഫോർമുല. ഇനി അതിൽ രണ്ട് കണ്ടീഷൻസ് വരും. അതിന് മുന്നാടി അതിന്റെ ലെങ്ത്തിന്റെ ജനറൽ ഫോർമുല f0 പ്ലസ് UE. f0 ഉം v0 അതിൽ ഈക്വൽ ആണ്, കാരണം ഇമേജ് ഫോക്കസിലായിരിക്കും, ഒബ്ജക്റ്റീവിന്റെ ഫോക്കസിൽ. ക്ലിയർ? അപ്പൊ അത് സെക്കൻഡ് ഫോർമുല. ഇനി തേർഡ് ഫോർമുല വരുമ്പോൾ രണ്ട് കണ്ടീഷൻ, മാക്സിമ മിനിമ. മാക്സിമ എന്നാ വരും? f0 by fe പ്ലസ് f0 by d. അത് തരണം. ഓക്കെ, ആ കേസിൽ ലെങ്ത് ഓഫ് ദ മൈക്രോസ്കോപ്പ് എന്ന ജനറൽ ഫോർമുല f0 പ്ലസ് UE. ഇനി മിനിമത്തിലോട്ട് വരുമ്പോൾ ഫോർമുല എന്നാ f0 by fe മാഗ്നിഫിക്കേഷൻ. ആ കേസിൽ ലെങ്ത് ഓഫ് ദ ടെലിസ്കോപ്പ് എവിടെ വരും? f0 പ്ലസ് fe എന്ന് വരും. ഓക്കെ, ഒരു വാട്ടിൽ കൂടെ കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിന്റെ ഇനി ഗോ ടു കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ് നോട്ട്ബുക്കിൽ. കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിന്റെ മാഗ്നിഫിക്കേഷന്റെ ഫോർമുല, രണ്ട് മൈക്രോസ്കോപ്പ് സിമ്പിൾ കോമ്പൗണ്ട്, v0 by u0 into d by UE. അവിടെ വെച്ച് ഒരു സൈഡിൽ വെച്ചു. ലെങ്ത് ഓഫ് ദ മൈക്രോസ്കോപ്പ്, look into the book. ലെങ്ത് എவ்வளോ? v0 പ്ലസ് UE. അത് ജനറൽ ആണ് ഇവിടെ കേട്ടത്. അത് ടെലിസ്കോപ്പ് ആകുമ്പോൾ v0 പോലെ f0 എന്ന് പോയിട്ടാ പോകും. അത് കൊടുക്കും. ഓക്കെ, ഇനി കണ്ടീഷൻ ഫോർ മാക്സിമം ഉണ്ട്, മിനിമം ഉണ്ട്. മാക്സിമ എന്ന് വരുമ്പോൾ ഇമേജ് ഫോർമഡ് വെയർ അറ്റ് ലീസ്റ്റ് ഡിസ്റ്റൻസ് ഓഫ് ഡിസ്റ്റിങ്ക്റ്റ് വിഷൻ. അതാണ് മാക്സിമ. അപ്പൊ മാക്സിമ വരുമ്പോൾ v0 by u0 ഫിക്സ്ഡ്. അതുക്കപ്പുറം സിമ്പിൾ മൈക്രോസ്കോപ്പിന്റെ ഫോർമുല സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. എന്നാ വരും? v0 by u0 into 1 plus d by fe. Correct, you are correct. ആ കേസിൽ length of the microscope is what? v0 plus UE, no change. ഇനി മിനിമം മാഗ്നിഫിക്കേഷൻ വരുമ്പോൾ v0 by u0 into d by fe. ആ കേസിൽ ലെങ്ത് ഈസ് ഈക്വൽ ടു v0 plus fe. Now you compare the two length formula of microscope and two length formula of telescope. മൈക്രോസ്കോപ്പിന്റെ ലെങ്ത്തിന്റെ ഫോർമുല എന്നാ v0 plus UE. കേട്ടല്ലേ? അത് മൈക്രോസ്കോപ്പ് ആയിരുന്നാലും ടെലസ്കോപ്പ് ആയിരുന്നാലും v0 plus UE. ഓക്കെ, ഇനി v0 plus UE എന്ന് പറഞ്ഞ ഫോർമുലയില് മൈക്രോസ്കോപ്പ് ആവുമ്പോൾ അതിലെ UE മട്ടും ചേഞ്ച് ആകും. യുക്ക് മട്ടും എന്നാ വരും? FE എന്ന് വരും. മൈക്രോസ്കോപ്പിൽ മിനിമത്തിൽ വരുമ്പോൾ FE എന്ന് വന്നു. ഇനി ടെലസ്കോപ്പ് ആവുമ്പോൾ v0 ബദല അങ്ക എന്നായിരിക്കും? f0. അപ്പൊ f0 plus UE എന്ന് വരും. ഇല്ലാന്നാ f0 plus എന്ന് വരും. അപ്പൊ എല്ലാം കണക്റ്റഡ് തന്നെ, ഒരു ചെയിൻ മാരിയതെല്ലാം ഇങ്ങനെ കണക്റ്റഡ് ആണ് അല്ലേ? സിമ്പിൾ മൈക്രോസ്കോപ്പ്, കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ്, അതുകൊണ്ടാണ് സിലബസിൽ സിമ്പിൾ മൈക്രോസ്കോപ്പ് ഫസ്റ്റ് വരുന്നത്, കോമ്പൗണ്ട് സെക്കൻഡ് വരുന്നത്, ടെലസ്കോപ്പ് തേർഡ് വരുന്നത്. അണ്ടർസ്റ്റുഡാ? സോ ദിസ് ടെലസ്കോപ്പ് ഈസ് കോൾഡ് റിഫ്രാക്റ്റിംഗ് ടെലസ്കോപ്പ്. ഈ ടെലസ്കോപ്പിന് ചില ഡിസ്അഡ്വാൻറ്റേജസ് ഉണ്ട്. ടു കറക്റ്റ് ദാറ്റ് വി ആർ ഗോയിങ് ടു reflecting telescope. It's not very much wider in the syllabus, but just to understand. Okay, adhu munadi we'll go to some defects of lenses. Okay, so below write the heading, aberration in the lenses. Aberration aberration in the lenses. Okay, we have to write a whole summary of the microscope and telescope. What is called aberration? Aberration the word meaning ketina, aberration is defect, problem. Okay, aberration means problem. Aberration. Okay, so below write aberration problems. Aberration means problem. Aberration means problem. Or we call it as defect, or we call it as issue. Some problem are there. Okay, aberration is this one. So two types of aberration. Aberrations two types with respect to lens. Okay, first one is called chromatic aberration. Second one is called spherical aberration. Okay, ഇതെല്ലാം theory ആണ്. There is less chance to ask a question, but as it is there in the syllabus, we can't skip and go. Okay, next you can write the heading of chromatic aberration. Okay. Aberration means I told you defect. What is chromatic? Word meaning is what? What is chromatic in physics? Colors. Monochromatic, single wavelength. Correct. We are going to learn the next chapters itself. Young's double slit experiment, blah 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 things. There we learn chromatic, monochromatic lights. So chromatic means light. So light defect means what? Which means our eye or any lens, I can say a lens is good provided the lens is able to focus it. Okay, our eye is like a lens. If you are not taken care, it will go to defect. Our defects eye in the defect rectify we are using specs. So what is the defect for eye? Eye is not able to focus it correctly, so that you are seeing the image in a blurred way. You are seeing the image in a blurred way. So chromatic aberration means light, means this white light which is consist of various colors, Webster colors, right? Violet, indigo, blue, red, green, all the colors will be there. So what is the main property of a lens? Means if a white color is coming into a lens has to focus everything on a common point. That is the best lens. But prism will not do like that. If a white light is passes through the prism will split the lights into various colors. Webster colors will prism splitting. A prism behavior lens lens is called aberration. What type of aberration? Chromatic aberration. So lens is not supposed to show like an prism. Lens in all colors one point meet. There is no aberration. If violet one point principal axis meet, indigo where principal axis meet, red where line meet, all colors split lens could pass split we call it as lens will have chromatic aberration. And the chromatic aberrations remove how we can remove that? That is lens in the make. Okay, lens in the making lens in the manufacturing defect that use in the material important. Lens in use in the materials. Normally once we are going to different shops, 10 rupees glass 4,000 rupees glass sunglasses. Okay, normally night drive we will use glass. Lens, bright light opposite vehicle bright light filter we have to see a clear visibility. That's why use pala lens pala but the effect different. That's lens cost difference. Chromatic aberrations main convex lens. Suppose white lights are coming, this is the focus in a simple term. And if a white light is coming, this white light is consist of what? Many colors. This white light is consist of Webster colors. All colors will be there. And what happen means when it is moving, all the colors should meet or should pass us through a common point. We call it as this light is a perfect one. Okay, this has no chromatic aberrations. Whenever if you see a chromatic aberrations, what happens? Now you have a different colors of lights are passing, like the Webster colors. After passing, one light will go here, another light will go here, another light will go here, like this. If these conditions, this is actually here also I am passing the Webster light only, but here I am getting violet, here I am getting indigo, here I am getting blue. Like this, if it is splitting like a prism, then I call this lens will have chromatic aberration. Okay, lens is dispersing the light. Dispersing. Equal to light in a dispersion. Our dispersing power is called, our dispersion it is called aberration. Lens is not supposed to do like that, but prism can do like that. So now it's called chromatic aberrations. Okay, this has chromatic aberration, this has no chromatic aberration. Understood? So below write chromatic aberration. The inability of the lens to focus, the inability of the lens to focus all the colors in a common focus. The inability of the lens to focus all the colors in a common focus is called chromatic aberration. Then draw the diagram. No chromatic aberration. Have chromatic aberration. The chromatic aberration, the chromatic aberrations will be there because it is splitted the colors. Every colors are joining at the principal focus at some common point. So the light, this lens can able to focus it, but the light cannot focus it. This is the real problem of our eye also. That's what we are using specs to correct the focus. Okay, that is called a spherical chromatic aberration. Chromatic means light. Light in a focus, the lenses have an inability to focus the colors in a common point. Next one, spherical aberration. The next heading, spherical aberration. Next heading, spherical aberration. Chromatic aberrations avoid பண்ணதுக்கு we have to use a correct material. That lens make in the material is important. In spherical aberration, the word itself indicates spherical. Means a lens will have two curved surface, right? One surface, second surface. This curving is smooth, at least I can say very polished. Polished, if a light is coming for example, if a light is coming, it is meeting at the focus exactly at the indent panana place at the focus. In case of spherical aberrations, in spherical aberrations, the problem is glitches at the surface, and the surface is smooth. That's spherical. Spherical surface is a defect problem. Now, in this case, this lighting pass panina, this is refractive, point place. Now, the correct, this is the focus, correct focus. Suppose I am assuming the focus has to happen at 10 centimeter. Instead of, because of the spherical aberrations, maybe the focus happens at 13 centimeter. Now, this is correct. This problem is because of the lens in the curvature and the defect. The correct polished. This will create a defect. This is called a spherical aberration. This will have spherical aberration. This has no spherical aberration. Okay, so below, right? Spherical aberration is due to the inability of the lens to focus the light beams, the inability of the light to focus the light beams due to the manufacturing defect, due to the manufacturing defects, due to the manufacturing defect of the lens, due to the manufacturing defects of the lens. A lens in the diagram you can do. Which one? The inability of the lens to focus. What I told you, the inability of the lens to focus the light rays due to the manufacturing defects of the lens. The manufacturing defects were now. This can be rectified by making the surface become smooth. This polish structure. Okay, we cannot see it in a 20 rupees lens aberrations. But we cannot recognize you can if you 4,000 or 5,000 Ray-Ban glass, if you are having a 40 rupees glass, you cannot see the difference. Explicitly you cannot feel, but the use any difference, especially sunglasses. Okay, so understood, right? We'll write some few additional theoretical points also. Next one, next heading. So ഇതാണ് ലെൻസിന് വരുന്ന നോർമൽ രണ്ട് പ്രോബ്ലംസുകൾ. ഓക്കെ, ഇനി ഡിസഡ്വാൻറ്റേജസ് ഓഫ് റിഫ്രാക്റ്റിംഗ് ടെലസ്കോപ്പ്. ഇപ്പോൾ പഠിക്കുന്ന ടെലസ്കോപ്പിൻ്റെ ഡിസഡ്വാൻറ്റേജ് പ്യൂർലി ജസ്റ്റ് തിയറി ഇതാ, ക്വസ്റ്റ്യൻസ് കേൾക്കുന്നതൊക്കെ ചാൻസ് കമ്മി ഇതാ, ബട്ട് ഇൻ സിലബസിലുണ്ട്. ഇൻ കേസ് ഒരു വന്നിന ഒരു റിസ്ക് അവോയ്ഡ് പണതുക്ക്. ഓക്കെ, ഡിസഡ്വാൻറ്റേജസ് ഓഫ് റിഫ്രാക്റ്റിംഗ് ടെലസ്കോപ്പ്. First one, star it point by point. For collecting more number of rays, for collecting more number of light rays to form, to collecting more number of light rays to form image of high density, image of high density, high intensity, image of high intensity, objective of large aperture is required. Objective of large aperture is required. Objective lens ne we need a big aperture. Object of large aperture is required. ഇതേമാതിരി പെരിയ അപ്പർച്ചറുള്ള ഒരു ലെൻസ് വാങ്ങുന്നത്, അത് നിറയെ ലൈറ്റ് റേസിനെ ക്യാപ്ചർ ചെയ്യണം. അപ്പോൾ ലെൻസ് ബിക്കം ബിഗർ ആൻഡ് ബിഗർ. ലെൻസ് ബിക്കം ബിഗർ ആൻഡ് ബിഗർ ആകുമ്പോൾ അത് ഭയങ്കര കോസ്റ്റ്ലിയാണ്, എക്സ്പെൻസീവ് ആണ്. ഓക്കെ, സോ വിച്ച് മീൻസ് ഇറ്റ് ഈസ് എക്സ്പെൻസീവ്, എക്സ്പെൻസീവ് ആണ്. ഹൈ ചാൻസസ് ഓഫ് ഹാവിങ് chromatic aberration and spherical aberration. High chances of having chromatic aberration and spherical aberration. കാരണം മാനുഫാക്ചറിങ് അவ்வளோ പെരുസല്ല, സോ ഈ റിസ്ക് വരതൊക്കെയുള്ള ചാൻസസ് ഉണ്ട്. ഓക്കെ, to eliminate these disadvantages, modern telescopes are using two types of modern telescopes. Two types of modern telescopes. ഈ മോഡേൺ ടെലസ്കോപ്പ് two types of modern telescope ഉണ്ട്. Two types of modern telescope. So before, okay, so right, number one, Cassegrain telescope. You hear the word of Cassegrain telescope. Cassegrain. Number one, Cassegrain telescope. Cassegrain telescope, number one. Second one is Newtonian telescopes. Newtonian telescope. The theory ആണ്, there is no formula, nothing. Newtonian telescopes. Cassegrain telescope and Newtonian telescope. This modern telescope is called reflecting telescope. The modern telescope is called reflecting telescope. Telescope. Below it, Cassegrain telescope consists of mainly a primary concave mirror and a secondary convex mirror. Light rays from an infinite objects. The light rays from an infinite objects falls first on the primary concave mirror, then on to the secondary concave mirror, After reflection from the secondary concave mirror, so convex mirror. After reflections from the secondary convex mirror, it is passes through an eyepiece lens. It is passes through an eyepiece lens. You can draw the diagram also. Secondary mirror, primary mirror. This is eyepiece lens. A reflecting type telescope ആണ്. അതാണ് Cassagrain. ഈ സ്ട്രക്ചർ നമ്മൾ Cassagrain. Secondary mirror, convex, primary, concave. Just a structure you can draw. Capture ഇതിനെ റിഫ്ലക്ട് ചെയ്തിട്ട് ഇതിനെടുക്കും. സോ ലെൻസസിൻ്റെ യൂസ് മിനിയേച്ചറാണ്. ഐ പീസ് മട്ടും യൂസ് ചെയ്യണം, വേറൊന്നുമില്ല. Newtonian telescope is marida, but a difference will use spherical structure. The Cassagrain telescope. Newtonian, you can also draw this one also. Newtonian telescope. Newtonian telescopes with a primary. That is the secondary way. Different of them parallel by which difference is structure convex mirror use type Cassagrain plain mirror use Newtonian telescope. Okay. All formulas are applicable. There are two formulas: maximum magnification, minimum magnification. What is M max you have? The formulas are applicable. The magnification, you can say magnification formulas applicable here. Then the magnification M max is equal to F0 by Fe plus F0 by D. M minima is equal to F0 by D. Finished up? ഇതിൽ ഒരു ഡിഫറൻസ് ഒന്നും കിട്ടില്ല. ഒബ്ജക്റ്റീവ് ഐ പീസ് ഉണ്ട്. ഐ പീസ് എന്ന് പറഞ്ഞാൽ ഇതിൻ്റെ ഫോക്കൽ ലെങ്ത്. F0 എന്ന് പറയുമ്പോൾ ഇതാണ് ഇവിടുത്തെ സെക്കൻഡറി മിറർ. അതായത് ഇതിൻ്റെ ഫോക്കൽ ലെങ്ത് ആണ് F0ക്ക് വരുന്നത്. ഇതാണ് ഒബ്ജക്റ്റീവ്. ഓക്കെ, ഇതിൻ്റെ ഫോക്കൽ ലെങ്ത് ആണ് ഇതിൻ്റെ കോൺവെക്സ് മിററിൻ്റെ ഇതിൻ്റെ ഫോക്കൽ ലെങ്ത് ആണ് F0. F എന്ന് പറയുന്നത് ഇതിൻ്റെ ഫോക്കൽ ലെങ്ത്. ഇത് ജസ്റ്റ് ഇതിൻ്റെ സപ്പോർട്ടിങ് അറേഞ്ച്മെൻ്റ് ആണ് ഈ പ്രൈമറി എന്ന് പറയുന്നത്. ക്ലിയർ ആണ്? ഓക്കെ. So we'll write, this is just a theory, just understand and then leave it. Anyway, chances for asking questions are less. Ini finished all this. In a notebook portrait model full page size edukana. You have to write the summary for complete formulas only. Microscopes nu mele eddi kodukka, note full single idana. Microscopes oru full page venam. Okay, do not write half page, quarter page, full page. Microscopes. Microscope ile simple microscope, SM, simple microscope. Okay, simple microscope. First formula, magnification. Tell me, M equal to, tell me, D by U naught. Okay, whatever lens is U naught and U naught to UE same. Second one, maximum magnification, M max ever 1 plus D by F, the focal length. Third one, M minimum is equal to D by F. ഈ കേസ് വരുമ്പോൾ ലെങ്ത്തിന്റെ ഫോർമുല എന്നാ? ഇതിൽ ലെങ്ത് ഇല്ല, അതിലല്ലേ കോമ്പൗണ്ടിലോട്ട് പോകുമ്പോൾ ലെങ്ത്. ഇതിൽ 3 ഫോർമുലാസ്, ഓൺലി ദാറ്റ്, റൈറ്റ്? നെക്സ്റ്റ് വൺ ഇസ് വാട്ട്? കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ്, CM, കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പ്. കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിലെ എമ്മിന്റെ ജനറൽ ഫോർമുല D by V naught by U naught into D by UE eyepiece. കേട്ടല്ല? ഈ കേസിൽ ഒരു ലെങ്ത്തിന്റെ ഫോർമുല കൂടെ ഉണ്ട്. ലെങ്ത് മീൻസ് വാട്ട്? V0 plus UE 10. ഇത് 1A 1B. ഇനി 2ലോട്ട് പോകുന്നു. 2ലോട്ട് പോകുമ്പോൾ M max, maximum magnification is what? V naught by U naught into 1 plus D by FE. ഇതിൽ പാർട്ട് A and part B. B means length. Length equal to same formula V0 plus UE. Same. Third one, part A, magnification minima is equal to what? V naught by U naught into D by FE. And the second part, length equal to V naught plus FE. ഇത് ഒരു സെറ്റ്, ഇത് അടുത്ത സെറ്റ്, ഇത് സെറ്റ്, എല്ലാം വേണം 3 സെറ്റ്. ഫസ്റ്റ്, സെക്കൻഡ് ആൻഡ് തേർഡ്. ഇനി നെക്സ്റ്റ് വൺ, ടെലസ്കോപ്പ്. ടെലസ്കോപ്പിന് 2 ക്ലാസിഫിക്കേഷൻ കൊടുക്കണം. ഫോർമുലാസ് എല്ലാം സെയിം ആണ്. റിഫ്രാക്റ്റിംഗ് ടെലസ്കോപ്പ്, റിഫ്രാക്റ്റിംഗ് ആൻഡ് റിഫ്ലക്റ്റിംഗ്. റിഫ്ലക്റ്റിംഗിൽ 2 എണ്ണം. വാട്ട് ആർ ദ തിങ്സ്? Cassegrain telescopes and Newtonian telescopes. Newtonian telescopes. Formulas are same. Formulas common on. Number 1, magnification M equal to V D by UE. Correct? Yeah? D by UE. Then the length of part A and part B. Look into your notebook. Length means what? V naught ku badala F naught ide formula plus UE. V naught ku badala adu varum. Okay? First part is over. Second part. M max. DLL F naught by U. F naught by U correct alla. Ini M max F0 by FE plus F0 by D. Part A and part B. Adile length evlo varum F0 plus UE nu varum. Second part. Ini idile third part. M minima equal to F0 by Fe. Part A, part B, length equal to F0 plus Fe. You can place everywhere modulus, okay? All are modulus. Magnification I have not placed to modulus. Very complex. Line everything is modulus in short, okay? Or you can write all are in, which means take only positive value, right? Take only U. Okay, we'll go back to the question paper. Back. We left a few questions, right? We'll complete that and we'll finish it. The handouts, last week we have discussed optics part, optical instrument we have not discussed. Please take the paper. All these formulas are important. And then I can answer. Okay. This is chance, but this is high chance. Okay. So we'll start with question number 7. Question number 7, I think, right? 7 is the first one we circled. 7. Spherical aberration in a lens is minimum when most of the deviation is at first surface, is minimum when most of the deviation is at the second surface, is minimum when total deviation is equally distributed over the two surfaces. That is the answer. Deviation rate adhika spherical aberrations adhika spherical aberrations minimum when is minimum when the total deviation is splitted across two different surface or distributed over two surface of the lenses. Equal distributed. The first surface is higher, second surface is higher, the deviation is but deviations minimum and equal distributed easier. I mean minima. Question number 9. A telescope consists of two lenses, focal length 0.3 meter and 3 centimeter respectively. 0.3 meter and 3 centimeter. Unit take care. It is focused on a moon by which subtended an angle of 0.5 degree at the objective. Then the angle subtended at the eye by a final image will be, which means we have to find out beta. Beta by alpha is equal to magnification. So what magnifications we can use will be here. A telescope consists of two lenses, focal length f0 0.3 meter. അപ്പോൾ f naught എவ்வளോ വരും? 3 സെന്റിമീറ്റർ. 3 സെന്റിമീറ്റർ എന്ന് പറയുന്നത് എவ்வளോ മീറ്റർ? ഇല്ല, ഞാൻ 2 സെന്റിമീറ്ററിലോട്ട് കൺവേർട്ട് ചെയ്യാം. 2 സെന്റിമീറ്റർ. ഇപ്പൊ ഫസ്റ്റ് വൺ 0.3 സെന്റിമീറ്റർ, 0.3 മീറ്റർ. അത് എவ்வளோ സെന്റിമീറ്റർ? f0 equal to 30 സെന്റിമീറ്റർ. fe equal to 3 സെന്റിമീറ്റർ. അത് രണ്ടും കിടച്ച്. It is object to moon which subtended an angle of 0.5 degree. 0.5 degree. 0.5 means what? Alpha or beta? Alpha. So below right. Visual angle alpha. Like that. Visual angle alpha is equal to 0.5 degree. What we need to find out? Visual angle beta has to be find out. Beta by alpha, telescope. What are the equations are available? f0 by fe, f0 divided by d. They are not specifying. See, question is not specifying whether it is maximum, whether it is minimum. If question is speaking anything about d only, whether it is maximum, whether it is minimum, then only you have to take this formula. Otherwise, we'll go with this minimum. Okay, so below right, if question is not specified, below right and hint. If question is not specified anything about d, then in telescopes consider the minimum magnification. D പറ്റി ഒന്നുമേ சொல்ல. അപ്പോൾ മാക്സിമം d at infinity or least distance of distinct പറ്റി ഒന്നുമേ പേസില്ലனா d വരുന്ന ഫോർമുല എടുക്കக்கூடாது. Okay, so m minima equal to f0 by fe. What is m? Beta by alpha. Everything is given. You have to find out beta. How much you are getting beta? 5 degree is the right answer. Okay, ini 11th question I guess, right? Okay, 11th question. A man's near point is 0.5 meter and far point is 3 meter. Power of the spectacle lens is required for reading purpose and seeing the distance object respectively. Here and additional point we have to learn near point and far point. Near point is first question reading purpose. Reading purpose. അപ്പോൾ ഈ നിയർ പോയിന്റ് എന്ന് പറയുന്നതും ഫാർ പോയിന്റ് എന്ന് പറയുന്നതും ഇമേജ് ഫോം ആകുന്ന പൊസിഷനാണ്. അപ്പോൾ നിയർ പോയിന്റ് എന്ന് പറയുന്നത് നിയർ പോയിന്റ് ഈസ് 0.5 മീറ്റർ വിച്ച് മീൻസ് ആൻ ഇമേജ് ഈസ് ഫോംഡ് അറ്റ് 0.5 മീറ്റർ. അതാണ് അതിൻ്റെ മീനിങ്. നെക്സ്റ്റ് വൺ, ഫാർ പോയിന്റ് ഈസ് അറ്റ് 3 മീറ്റർ വിച്ച് മീൻസ് ആൻ ഇമേജ് ഈസ് ഫോംഡ് അറ്റ് ഫാർ അവേ പോയിന്റ്. രണ്ട് കേസ് അത് രണ്ട് ഇമേജ് ഫോം ആവുന്നുണ്ട് എന്നാണ് അതിൻ്റെ മീനിങ്. നിയർ പോയിന്റ് 3 മീറ്റർ, എവിടെ 3 അല്ല 0.5 മീറ്റർ. ഫാർ പോയിന്റ് 3 മീറ്റർ. ഇത് രണ്ടും അതിൻ്റെ രണ്ടിൻ്റെ മീനിങ് എന്നാ ഇമേജ് ഫോം ആകണമെന്ന കേസ്. ഓക്കെ, അതായത് ഫസ്റ്റ് കേസിൽ ദേ ടോൾഡ് വൺ യു ക്യാൻ ഇന്റർപ്രിറ്റ് ദ ക്വസ്റ്റ്യൻ ലൈക്ക് ദിസ്. ഇമേജ് ഈസ് ഫോംഡ് അറ്റ് 0.5 മീറ്റർ. I mean very closer image and a very far away image is formed at 3 meter. അപ്പോൾ രണ്ട് ഇമേജ് ഡിസ്റ്റൻസ് ആണ് നല്ല മീനിങ്. ഇനി ക്വസ്റ്റ്യൻ്റെ രണ്ട് സെക്കൻഡ് പാർട്ട് റീഡിംഗ് പർപ്പസ്. റീഡിംഗ് പർപ്പസ് ആകുമ്പോൾ ഒബ്ജക്റ്റ് ഈസ് ഷുഡ് ബി വേർ near means least distance of distinct vision. Appo u equal to -25. So please write for reading purpose u equal to -25 centimeter. Correct alla? U equal to -20. Aa case ilana you told a word called near. So you are getting a near image. Near image where? So u equal to -25. So v equal to how much you will get? V is equal to what? 0.5 meter. You centimeter lana 25 centimeter. So we also we need to convert into centimeter. So v equal to -50 centimeter. കാരണം ഇത് സിമ്പിൾ, ഇത് കോമ്പൗണ്ട് മൈക്രോസ്കോപ്പിന്റെ കേസില്ല. ലെൻസ് മീൻസ് അവർ ഐ വിച്ച് മീൻസ് ഇറ്റ്സ് എ സിമ്പിൾ മൈക്രോസ്കോപ്പ്. Our eye is a simple microscope. So u equal to -25 centimeter, v equal to -50 centimeter. അത് രണ്ടും നമുക്ക് അടിച്ചു. Then അതിന്റെ പവർ കണ്ടുപിടിക്കണം. Power means what? 1/f. So please find 1/f. Please find 1/f. value കണ്ടുപിടിക്കണം. 1/f. Just speaking about question number 11, please find the value of 1/f. U equal to minus 25 centimeter, V equal to minus 50 centimeter. Lens makers formula substitute edittu adile 1 by F aanu power. Dharani, how much answer? Minus 2D diopter. ഡയോപ്റ്ററിൽ എടുക്കുമ്പോൾ മീറ്ററിൽ ആണ് യൂണിറ്റ്സ് എടുക്കേണ്ടത്. എപ്പോഴും അത് മീറ്റർ ഇൻവേഴ്സ് ആണ് ഡയോപ്റ്റർ, സെൻറ്റിമീറ്റർ ഇൻവേഴ്സ് അല്ലാതെ. -2 ഡയോപ്റ്റർ സ്റ്റീവാക്ക്, -2 ഡയോപ്റ്റർ അത് റീഡിംഗ് പർപ്പസിനുള്ളതാണ്. -2 ഡയോപ്റ്റർ ഇത് കറക്റ്റാണ്. F 50 സെൻറ്റിമീറ്റർ ആണ് അല്ലേ? അപ്പോൾ എന്നാ കണ്ടുപിടിക്കണം? ഡയോപ്റ്റർ പവർ കണ്ടുപിടിക്കണം. 1 by F, 1 by 50 സെൻറ്റിമീറ്റർ തന്നെ മീറ്ററിലോട്ട് കൺവേർട്ട്. 50 × 10⁻², 100 മേലെ പോകും. പോസിറ്റീവ് നെഗറ്റീവ് +2 ആ. സോ +2 ഡയോപ്റ്റർ. അപ്പോൾ കറക്റ്റാണ്. +2 ഡയോപ്റ്റർ. +2 ആ. കാൽക്കുലേഷൻ ആണ്, വേറെ ഒന്നുമേ. +2 പ്ലസ് താ വരും, കാരണം 25 പോസിറ്റീവ് അതാ വരും. മറ്റേ -50 ഹയർ നമ്പർ പോസിറ്റീവ് ആകുമ്പോൾ ഹയർ മൈനസ് ലോവർ പോസിറ്റീവ് ഇതാ വരും. +2 ഡയോപ്റ്റർ. +2 ആ. സിമ്പിൾ അല്ല. മാത്തമാറ്റിക്സ് 3rd സ്റ്റാൻഡേർഡ്, 4th സ്റ്റാൻഡേർഡ്, 5th സ്റ്റാൻഡേർഡ് അതാ കേൾക്കണം. 1 by -50 പ്ലസ് -1 by -25. കറക്റ്റ് അല്ലേ? +2 ഡയോപ്റ്റർ എന്ന് വരും ആൻസർ. സെക്കൻഡ് പാർട്ട് ഓഫ് ദ ക്വസ്റ്റ്യൻ. Seeing a distant object means U equal to -infinity. ആ ഡിഫറൻസ്. Seeing a distant object means U equal to -infinity. ആ കേസിൽ V എവിടെ വരും? V equal to 3 meter. What 3 meter? Minus or plus? -3 meter. V equal to -3 meter. അപ്പോൾ U equal to -infinity, V equal to -3 meter. അപ്പോൾ പവർ വരും എവിടെ? പവർ -0.33D എന്ന് വരും. So what will be the answer? Option C is the answer. Everybody understood? Got it? Light mode okay. Up 13. 13. A telescope has an objective focal length f0 100 cm, eyepiece focal length 5 cm. What is the magnifying power of the telescope when the final image is formed at the least distance of distinct vision? Final image is formed at the least distance of distinct vision. Magnifying formula f0 by fe into f0 divided by d. f0 given in the question. f0 is 100. fe is 5 cm. d is how much? 25. So you will get the answer as 24. Good. 18. I think the next one is 18. If I'm missing anything, tell me. Okay. 18. Next question is 18, 20. Adukapram. What are the things we marked? 18, 20, 31, 32. That's all. Okay, so 18. A compound microscope has an eyepiece focal length 10 cm. Objective focal length 4 cm. Calculate the magnification if an object is kept at a distance of 5 cm from the objective so that the image is formed at the least distance of distinct vision. D equal to 20 cm. So which formula? Simple microscope, compound microscope. Compound microscope. Image is formed at the least distance of distinct vision. 1, 2, 3. Maximum 2. V0 by U0, 1 by D by Fe. This has to find out. Okay, what are the values given? Eyepiece in the focal length FE is given. Correct alla? F is equal to 10 centimeter. Objective in the focal length F0 is given. F0 is given. But what is given? Object is kept at a distance of how much centimeter? 5 centimeter. So U equal to minus 5. F0 equal to 4. So you can find out V0. Correct alla? Then to find out V0. V0 and the value mattu solunga first.
20.
Then substitute here. We noted 20 kadachina, what we have to do next? This formula substitute cheyyanam, correct alla? Substitute cheyidana oru answer varum, and the answer option irundana 4 mark illena avladha. 12 is there, 12 10 13. All these things you already studied in schools, right? Microscope school எடுக்கவேல, ஸ்கூல் எடுத்துக்கிங்களா? அப்ப பின்ன டக்கு ஆன்சர் சொல்லணும். ஓகே, இப்போ 18th ஆன்சர் 12 ன்னு வரும் பாத்தீங்களா? நீட்டா நம்ம நோட் புக் முடிஞ்சனா நான் வாங்கிச்சறேன். அவ்வளவுதான். 20. Question number 20. We'll go to the next question now. All of you got it down? 40 na, appo idu thappu irukku. Idu correct da. V not evlo 20. Appo idu correct. Appo inga substitute 20 by minus podana sollinga. All are positive. All are in modulus, take only positive values. So 20 by 5. Sollina 4. 1 plus d by d sollina 20 alla question il koduthirukka 20 cm koduthirukka 25 alla 20 20 by 10. അപ്പോൾ ഉള്ള വരും 2. കറക്റ്റ് അല്ല? 1 plus 2 3 into 4 12 വന്ന് അவ்வளவுதான். Okay, in this question capital D is how much? In this question capital D is how much? 20 centimeter, not 25. അപ്പോൾ അടുത്ത question 20 ആൻസർ சொல்லுங்க. Question number 20. Question number 20 answer. A person can see clearly only up to a distance of 30 centimeter. He wants to read a book at a distance of 50 centimeter. Okay, so he said, what is the power of the lens? This question is typical. Typical a person can see clearly only up to 30 centimeter. He wants to read a book which is placed at a distance of 50 centimeter. Appa idu direct ആയിട്ട് objective distance ഉം image distance ഉം ഉള്ളതുക്ക് പകരം indirect. A person can see clearly only up to a distance of 30 centimeter and he wants to read a book is placed at a distance of 50 centimeter. So book is placed at a distance of 50 centimeter. So U equal to minus 50. Okay, and he can see the object up to where? He can see the object means a book create an image on. A book create an image in the way V is equal to how much? Minus 30. A book 50 centimeter വെച്ചിരിക്കുന്ന ബുക്കിന്റെ ഇമേജ് ആണ് he is seeing at 30. 30ക്ക് മേൽ അവർക്ക് he is not able to see. അപ്പോൾ book is at a distance of 50 centimeter means U equal to minus 50. Image is forming where? V equal to minus 30. ഇനി അതിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. 1 by F കണ്ടുപിടിക്കണം. minus 1.33 diopter. Okay, diopter വരുന്നത് எல்லாமே மீட்டர்ல எடுக்கும்போது தான். நீங்க சென்டிமீட்டர்ல கழிச்சதுக்கு அப்புறம் மீட்டர்ல கன்வர்ட் பண்ணணும் 1 by F നെ. അപ്പോൾ ദാ diopter വരുന്നത്. Diopter is meter. കാരണം majority of the students make mistakes ആണ്. Diopter is meter inverse. Diopter is not centimeter inverse. Centimeter inverse എടുത്ത ആൻസർ കിടച്ചിട്ട് ഇതിലിരിക്കും മോസ്റ്റ്ലി. അതല്ല അതിൻ്റെ ആൻസർ. മീറ്ററിൻ്റെ ഇൻവേഴ്സ് എടുക്കണം. അപ്പോൾ എഫ് മീറ്ററിൽ കണ്ടുപിടിക്കണം. എന്നിട്ട് 1/f എടുക്കുമ്പോൾ you will get the power in terms of diopter. So minus 1.33 okay, minus 1.33 diopter. 20th option B. We'll go to 31. A microscope is focused on the mark on a piece of paper, and then a slab of glass of thickness 3 cm, refractive index 1.5 is placed over the mark. How should the microscope should be moved to get the mark in the focus? ഇതിൻ്റെ ലോജിക് എന്താ കേട്ടിന? Microscope is focused on a mark of paper, a piece of paper, and then a glass slab of thickness 3 cm and a refractive index 1.5 is placed over the mark. How should the microscope is moved to get the mark in the focus again? അതിന്റെ മീനിങ് എന്നാ? ഇതാണ് ഗ്ലാസ് സ്ലാബ്. ഗ്ലാസ് സ്ലാബിന്റെ തിക്നെസ് 3.5. കറക്റ്റ് അല്ലേ? ഇതിന്റെ T is മാർക്ക് എടുത്തതിന് അതിന്റെ ഒറിജിനൽ ഡെപ്ത് എവ്വളോ? ഇത് ഒറിജിനൽ ഡെപ്ത് അപ്പാരന്റ് ഡെപ്ത് കോൺസെപ്റ്റ്. ഒറിജിനൽ ഡെപ്ത് എവ്വളോ? 3 cm. ഇപ്പൊ ആ ഗ്ലാസ് പീസിലൂടെ പാക്കുമ്പോൾ വിൽ ഫീൽ ദിസ് മാർക്ക് വിൽ ബി ഹിയർ. ഓക്കെ, ഈ മാർക്ക് ഇരിക്കുന്നത് എന്നാ? ഇതെന്നാ? അപ്പാരന്റ് ഡെപ്ത്. വാട്ട് ദേ ആർ ആസ്കിംഗ്? ഷിഫ്റ്റ്. How to find out the shift? Shift is equal to original depth by apparent depth. Original depth minus original depth divided by refractive index. ആ ഷിഫ്റ്റ് കണ്ടുപിടിക്കുക. ഷിഫ്റ്റ് പോസിറ്റീവ് കിടച്ചാൽ അപ്വേർഡ്, ഷിഫ്റ്റ് നെഗറ്റീവ് കിടച്ചാൽ ഡൗൺവേർഡ്. അത് ഷിഫ്റ്റ് എപ്പോഴും അപ്പ് സൈഡ് ആയിരിക്കും, പോസിറ്റീവ് ആയിരിക്കും. സോ വാട്ട് ഈസ് ഒറിജിനൽ ഡെപ്ത്? 3 cm minus 3 cm divided by refractive index is 1.5. That means 3/2. So 3 minus എവിടെ വരും? 2, which means 1. You will get plus 1. Definitely you will get plus 1. 1 cm upward. ആ ഷിഫ്റ്റ് ആണ് അങ്ങ് കേൾക്കുന്നത്. വേറെ ഒന്നുമല്ല. ഇതാണ് ക്വസ്റ്റ്യൻ നമ്പർ 31ന്റെ ആൻസർ. Question number 32. What causes chromatic aberration? Variation of focal length of the lenses with respect to color. I hope you have no doubts. Okay, so done. Optics. Normally I will take 18 hours, but this time I have taken 22 hours. Okay, 4 hours more. Okay, then see you in the next class. Bye.